about 20 liters of alcohol. 10 liters were distributed to some checkpoints in Mapalad and Steel Town. The 7.5 liters will be given to Task Force COVID for them to distribute as per instruction. The remaining will be reserved for laboratory use. As of April 14, the group were able to develop a bioethanol production model. They did not release the product after its validation because it is not yet necessary, and aside, it needs permission from your office to push through the bioethanol production. If the trend of the COVID-19 continued to increase, 2,633 confirmed cases as of April 2, 2020, then the supply of the ventilator will become scarce. For this reason, the MET department with its team College of Engineering and Technology initiatives on combating COVID-19. The Cabinet was one of the first initiative of the Institute during the start of COVID pandemic. This Vietnam sterilization chamber-inspired cabin was designed using local-made materials and can be replicated easily by interested parties. This project was led by Dr. Carl John Salaan, assisted by Dr. Vani Joy Resabal, and made possible through helping hands of COET faculty, students, and alumni. The project cost is estimated at 75,000 pesos, which include the labor and materials. From the team's assessment, cabinets is more appropriate to be installed in hospitals' entrances. Its main concern was the disinfection compound, which utilizes household bleach instead of anolite attending the infected COVID-19 patients. This equipment cost about 2,500 pesos. To complement the supply of ethyl alcohol for sanitation and disinfection, the 𝗘𝗟𝗘𝗘𝗥𝗓𝗡 department produced bioethanol. The team is composed of the following: Dr. Alex Mosqueda, team leader, Professor Catherine Achibar, Professor Ching Dizon, and Professor Eulalio Criensha. As of April 1st, the group were on the process of experimentation. As was suggested, the produce will be presented to Task Force COVID and to Dr. Mylene Oy for validation and clearance. Aside from the bioethanol production, the team diluted concentrated alcohol and produced about 20 liters of alcohol. 10 liters were distributed to some checkpoints in Mapalad and Steel Town. The 7.5 liters will be given to Task Force COVID for them to distribute as per instruction. The remaining will be reserved for laboratory use. As of April 14, the group were able to develop a bioethanol production model. They did not release the product after its validation because it is not yet necessary, and aside, it needs permission from your office if it pushed through the bioethanol production. If the April 14, 2020, the team successfully calibrated their prototype and is now currently working on the breathing circuit before the demonstration. Currently, the MSU IIT open source easy ventilator, MOSEV, is looking for some funding for processing the regulatory requirements as imposed by Food and Drug Administration, FDA. The team MOSEV also wishes to share its technology to all interested parties who wants to help in combating this COVID pandemic. For its development, these gadgets cost about 50,000 pesos.
Being the pioneer and a leading institution to establish a niche in microelectronics integrated circuit design in southern Philippines, MSU IIT's Microelectronics Laboratory is leveling up its endeavor by engaging a system-on-chip integrated circuit design development. Over the years, it has been promoting innovation and awareness in microelectronics IC design in Mindanao by offering courses and trainings that will enhance and provide advanced skills to aspiring IC design and layout engineers in the region. As a result, the Microelectronics Laboratory has been producing more highly skilled engineering graduates to answer to the increasing demand for professionals with strong background and skill set in IC design. The Microelectronics Laboratory has accepted the challenge of the ever-growing demand in IoT devices. It has dedicated its pool of talents and resources to develop its first contribution to the demand. The Enlight chip, an energy harvesting chip that aims to extend the battery life of existing IoT devices. It is capable of extracting indoor light energy to recharge a nickel metal hydride battery used for wireless sensor networks applications. This two-year endeavor is supported and funded by USAID, a program that has the goal to stimulate inclusive economic growth by boosting science and technology research. Building upon the success of the Enlight chip, the Microelectronics Laboratory took a major leap towards designing a system-on-chip solution for wireless sensor network applications, which is made possible with its funding agency, the DOST-PSHIRT, the mandated Philippine Council in the implementation of strategies in the industry, energy, and emerging technology, research, and development sectors. With 3.5 years of implementation, the project started a modular approach in designing the system on a chip. which is composed of an energy harvesting unit, a power management unit, and a microcontroller. The modular approach lessens the complexity of the design and ensures an optimized and functional circuit performance. The final year develops a versatile system-on-chip design. The MCU, PMU, and EHU are combined onto a single integrated circuit chip, thus giving birth to the final product of the project, the iecp.iliganbaychapter chip. The iecp.iliganbaychapter chip will be utilized to develop a customized wireless sensor node, which is an IoT device used to monitor environmental conditions such as temperature, humidity, pressure, and light. The wireless sensor node is composed of 3 fully customized circuit boards. The top board houses the PV cell for the light energy harvester and the sensors used based on the desired application. The middle board includes the RF module, which is essential for wireless communication purposes. Lastly, the base is the main with the technology used in this project, the IIPUC8K1612 only transmits a continuous wave at a short period, which is during data transmission. Now let's go back and take a closer look at how the WSN works. The WSN consists of 3 ultra-low power sensors such as pressure sensor, humidity with temperature sensor, and the ambient light sensor. The IIPUC8K1612 chip is pre-programmed to read the data from the sensors. A stackable header is used for access to the sensors and the transceiver boards. The transceiver board is equipped with the analog devices ADF7024 transceiver IC with a 433 MHz chip antenna. It allows wireless transmission of sensor data to a gateway. The Raspberry Pi acts as the gateway and is interfaced with another transceiver board to allow wireless reception of data from any node. As the WSN powers up, it automatically reads data from the sensors and transmits the data to the gateway. Once data from any sensor node is received, the gateway is configured to transmit the data to an HTTP server. Multiple nodes can be networked together and placed in various locations of a building to monitor the surrounding environment. This allows data to be displayed in the mobile app. It shows the information on each of the sensor nodes, such as the sensor node's ID, location, battery level, as well as the readings of the available sensors. Here, we can see the temperature, humidity, pressure, and ambient light readings. To scan through the other sensor nodes available, we click on the arrow buttons. Information such as the RSSI, the timestamp of the recent data, and the status of the node, whether active or inactive, is also displayed. Clicking on a sensor reading shows a graph of the historical data of that sensor, along with the timestamp of the data points. If you long press on the graph, an option to clear the data will show. The number of samples that the graph can show can be configured in the settings menu. The refresh rate, which is the interval at which the app will query the server for new data, can also be configured here. The user can also set minimum and maximum threshold values of the sensor readings. Clicking on the Set Limits Values will show a dialog box where the user can input these limits. Once the sensor readings reach the limits, the app can notify the user. Enabling the toggle switch will enable the notification feature when the limits are breached. The value of the sensor reading and the graph will turn red when the maximum limit is breached. It will turn blue if the minimum limit is breached. Even if the app is running in the background, the app will notify the user when the battery of the sensor node is low or when the limits are breached. The mobile app shows seamless remote monitoring of data from the deployed sensor node at any time and anywhere in the world through the internet connectivity. Sensor networks can also be used in applications like smart buildings, smart agriculture, smart homes, healthcare, structural monitoring, transportation systems, and many others. Indeed, WSN has a continuously growing range of applications that help improve human lives up to the present day. Driven to develop, innovate, and be the pioneers of research and development in integrated circuit design in southern Philippines, and to cultivate microelectronics IC design awareness in Mindanao, MSU IIT's Microelectronics Laboratory responded by designing an integrated circuit chip, a 3-year project funded by DOST with over a budget of 31 million pesos. One of the many key features of this microcontroller is its ability to tap into the telecommunication devices, which can further improve management systems. With the use of this developed technology, phones, tablets, or even the computers of individuals who enter the premises can be prompted to preview the necessary aid in the event, for example, that there is a need for evacuation or rescue. Aside from that, through the use of a network of sensors, the microcontroller is capable of monitoring an entire environment and status of an establishment or given area in real time. Data on factors such as temperature, humidity, and even the presence of physical movement can be processed and utilized to automate, say for example, the switching of indoor light or even air conditioning temperature control in an area. With the microcontroller's self-sustaining mechanism, it would enable industries and sectors alike to monitor, record, and organize data directly from the microcontroller. This way, sites or facilities are monitored 24/7 without the need to send personnel directly to the location, making the whole process greatly accelerated and undemanding. agriculture can find an effective use of this technology by providing their facilities a more advanced method of approach concerning crop and environment maintenance. With the extensive and promising potential of this highly reliable technology, the way smart buildings, smart agriculture, industries, management systems, and sectors alike will be able to operate and function to a higher and better degree, thus paving a way to a more enhanced and progressive performance in the workplace.
This is the Electronics and Communications Laboratory of MSU-IT. Inside are facilities and technologies that allowed us to design and develop communication systems for a wide range of applications. One of which is the system that uses wireless electromagnetic radar for groundwater detection. It is funded by 𝗘𝗟𝗘𝗥𝗡𝗅. The project aims to first evaluate the ability of electromagnetic waves to detect underground water, estimate its depth and quantity. Second, map areas with possible sources of water.
This program allowed us to practice and apply digital signal processing and RF engineering. These are knowledge and capabilities we gladly
Good afternoon. Before we properly begin the webinar, we have some few announcements to make. First, the nomination for a new set of officer for iecep.iliganbaychapter is now going on. The link for nomination was already shared through the registered email of our local members. We are encouraging everyone to nominate those deserving and willing active members of iecep.iliganbaychapter to serve our local chapter. Later, during the General Assembly, we will be announcing the top 3 nominees for each position, and the voting will begin afterwards. Second announcement, the ICEP Mid-Year Convention is around the corner, and the registration is now open. You can register through the event shopping on your myicep.net account. So I hope everyone, ICEP IBC members, will register for the Mid-Year Convention this coming June. You can join through online or on-site. The on-site will be on Davao City. Again, good afternoon mga ka-ICEP IBC, and welcome to iecep.iliganbaychapter in partnership with MSU Iligan Institute of Technology, first free technical webinar for the year 2022, with the title Electronics Engineering and Space Science and Technology. In this webinar, We have put together 3 interesting topics on the field of space science and space communication. And we have invited experts, engineers, and researchers to discuss these topics. I am Engineer Kevin Maglinte.
And I am Engineer 𝗘𝗟𝗘𝗥𝗓𝗚𝗚𝗍𝗍.
Okay, and I am Engineer 𝗘𝗟𝗘𝗧𝗥𝗢𝗡𝗆.
And we will be your host for today's webinar. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You will have the opportunity to submit the text questions to today's presenter by sending your questions on the link flash on the screen. You can also access the link by scanning the QR code on the screen of for your questions. You may send in your questions at any time during the presentations. We will collect this and address them during the Q&A portion at the end of every presentation. Sorry for those technical difficulties. Also, there's an online quiz to assess your understanding for the presentation every after the Q&A portion. The link to the online quiz will be and the evaluation will be shared in the chat panel and will be projected on the screen. This also serve as your attendance and will be the basis for your CPD certificate for this webinar. We would like to start this program through a prayer followed by the national anthem.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang magiliw, kelas ng silanganan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyag ka ng magiting, sa manlulupin, di ka pasisigil, sa nagatang putok sa simoy at sa langit ng pagaw, ay hinatang tulang awit sa pagkayang minamahal. Ang isang ng watawat mo'y tagumpay na nagtitinig, ang bituin at araw niya kailan pamay magtitinig. Lumagang araw ng warhagin pagsinta, buhay langit sa piling mo. Ang inigaya ng pagkay hangami, ang mamatay ng dahil sa'yo.
Almighty, loving, and merciful Father, Creator of everything and source of wisdom, knowledge, and understanding. We adore you for your infinite wisdom and power. We praise you for you are the only one who can direct our lives. We thank you for all the gifts you have bestowed on us, your children. Without you, we are nothing. You are the ultimate teacher. You teach and instruct us in the way of life and guide us into your will. May we teach others with the wisdom and love that we receive from you. Remind us that our teaching is an act of worship to you. Amen.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Arrahmanirrahim. Malik yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Rabbana dalamna wa ilaika tawakkalna wa ilaika anabna wa ilaikal masir. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Rabbana waj'alna muslimaini laka wa min dzurriyyatina ummatan muslimatan lak wa arina manasikana wa tub 'alaina innaka antat tawwabur rahim. Rabbana dalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana taqabbal minna innaka antas samiul alim wa tub 'alaina innaka antat tawwabur rahim. Birahmatika ya arhamur rahimin walhamdulillah.
All right, so good afternoon, everyone. Once again, to formally begin this webinar, I would like to invite our iecep.iliganbaychapter Governor Engineer 𝗘𝗡𝗚𝗎𝗺 to deliver the opening remarks. Ma'am?
Good afternoon, everyone. So, to all distinguished participants, students, and my fellow engineers of science and technology innovation, I am pleased to welcome you to the webinar of 𝗘𝗚𝗡𝗺𝗺 of Electronics and Communication Engineer in collaborations of Mindanao State University Iligan Institute of Technology. This platform is one of many online webinars conducted by Space Science of the Philippines on sustainable development of goals of electronics engineering in space science, technology, and innovations in the Philippines. It aims at providing key inputs to the endeavor of the Philippines to build Filipino satellites in nanosatellite engineering to help countries' economic, territorial, and disaster risk reductions efforts. In this virtual conference room, we have two speakers, both pioneering Filipino satellite builders in nano-satellite engineering of the Philippine Space Science, and proud to say alumni of MSU IIT, and one of RF communication experts from Taiwan to give us talk about space technology. We all understand the importance of space science, technology in our day-to-day lives and the ways in which they are transforming the world. If this was not clear earlier, it is obvious that now in the time of war in Ukraine and Russia, science and technology and innovations are indispensable for our response to and recovery from this crisis. Ladies and gentlemen, I believe that by participating in this webinar, we are in the right place and right time. Together, let us accelerate the exchange of ideas and scaling up of good practices. I am confident that you will find new ideas, fresh energy, and novel partnership to sustain your efforts in support of Philippine space technology through science, technology, and innovation. I wish you all a very successful webinar. Thank you.
All right, so that was Engineer Olga Joy L. Herasta, our iecep.iliganbaychapter governor. Thank you, ma'am, for those wonderful remarks. Just for the information of everybody, again, there is an online quiz to assess your understanding of the presentation every after the Q&A portion. The link to the online quiz and evaluation will be shared in the chat panel and will be projected onto the screen. This also serves as your attendance and will be the basis for your CPD certificate for this webinar. So you should listen to every speaker that we will be having this afternoon. So let me introduce to you our first speaker. He graduated last June 2018 at Mindanao State University, Iligan Institute of Technology with a degree in BS in Electronics Engineering. He worked as a science research specialist too at PHL-50 project Stamina for Space program at University of the Philippines, Diliman. He also worked as a senior science research specialist on the ASP project Stamina for Space program at University of the Philippines, Diliman, and currently he is a senior science research specialist at Philippine Space Agency. He specializes in satellite engineering, particularly in attitude and orbit control systems engineering. So without further ado, let's welcome our first speaker for today's webinar, Engineer Kenneth John Ibarra, who will talk about Philippine Space Agency and overview on the spacecraft systems engineering. Sir?
Hello. Good afternoon, everyone. Thank you for that very warm welcome. And also thank you for the iecep.iliganbaychapter for inviting us to present the Philippine Space Agency, as well as presenting some of the developments of our country in terms of space technology. So to start, I'm just gonna share my screen. I hope everyone sees this. So my goal for this session will be to discuss to you the Philippine Space Agency on the first part, and on the second part, I will give you an overview of the spacecraft systems engineering. So to start, I will give an outline on the Philippine Space Agency on how it was established, the mandate of PhilSA, and the past developments that we have gone through the years of space technology. And also, to end my note is to give you on the reasons why we are exploring space, or to give you the value of space and why we are exploring the outskirts of space. So the Philippine Space Act was established just 3 years ago, signed by our president, and it was effective in the year 2019, September. The Philippine Space Act consists of the Philippine Space Council, which is under the office of the President, as the chairperson of the Space Council. It also consists of the advisor body, which consists of the Philippine National Defense, and of course the Science and Technology chairmen. And of course, we have the Philippine Space Agency as the secretariat of the council. So here shows you the mandate of PhilSA, or these are the key development areas or the directions that we are aiming to when we are doing our activities in PhilSA. This acts our guiding principle when we are doing our policies and projects. So a highlight on this is on the space education and awareness, as what we are doing right now is proliferating and expanding space technology into different institutions and of course organizations that we can share knowledge and expertise on space technology. So to show you also that PhilSA is not reinventing the space technology, but we are building upon the past developments of research on space and investments. So we have here the different organizations and programs that were previously aligning with the development of space technology. So these are the programs that developed the 𝗲𝗺𝗏-1 satellites, 𝗲𝗺𝗏-2 satellites, and I will show you later on those different portfolio of satellites that we have been developing in the past years. So to start, we have this list of satellites that are currently in use and access as of 2020. So there are already satellites that in progress today that are being developed, but I will not discuss more on them as they are in the development stage yet. So first, I will show you the 𝗲𝗺𝗏-1. So this is the 𝗲𝗺𝗏-1. 𝗲𝗺𝗏-1 is a microsatellite. So a microsat, it is a 52 kilogram satellite, and typically microsats have type 2. The mission is for scientific Earth observation. So when we say Earth observation, its mission serve as for imaging pictures or to different areas of the Earth. So as for example, taking images of the Philippines or taking images on our agricultural areas so we can assess the development. And of course, it was also used for disaster response and management, environment and resource assessment as well. So you can see here the technical specifications of the 𝗲𝗏-1, the dimensions, and it is a low Earth orbit satellite with the following payload. We have the high precision telescope, a spaceborne multispectral imager to capture different bands of spectral images. And we also have the middle field and wide field camera. So the 𝗲𝗺𝗏-1 was launched before in March 2016, and it's already been decommissioned just 2 years ago on April 2020. So just a trivia, 𝗲𝗺𝗏-1 is the first Filipino-built satellite under the PHL Microsat program, which was in partnership with the Hokkaido University in Japan, Tohoku University. This is an image of the release of the 𝗲𝗺𝗏-1 in NASA ISS station. Next, the coming satellite that followed our very first on 𝗲𝗺𝗏-1 is the 𝗲𝗺𝗏-2. So it's also a microsatellite, and it weighs heavier than the 𝗲𝗺𝗏-1, which is around 57 kilograms. It is also an Earth observation satellite. One of the main difference between the 𝗲𝗺𝗏-1 and the 𝗲𝗺𝗏-2 is the 𝗲𝗲𝗏-2 is a sun-synchronous orbit. So sun-synchronous means that the satellite follows the rotation of the Earth around the sun. So as to make sure that the images captured by the 𝗲𝗏-2 is always illuminated by the sun. So the payloads are almost the same, with the differences on the addition of the amateur radio unit, which is used for amateur radio communications. We also have technological developments in terms of sun sensors and also attitude controls. This satellite was launched on October 2018, and up to now is still in orbit as of this moment. And these are the missions that it was used for. The same almost mission with the Diwata one, which is for multispectral imaging and to disaster management and resource management also of the farms and the fisheries of our country. Diwata 2 is also built under the 𝗘𝗟𝗘𝗥𝗓𝗄 microsat program, and the stamina and was further developed by the Stamina for Space program. So this is an image of the Diwata 2 engineering model. Next, we have the Maya 1. So this one is a smaller version, a much smaller type of satellite we call the CubeSat. It weighs almost 1 kilogram, and the main purpose of CubeSat is usually for technology demonstration and for educational purposes that we can use for training students or institutions that are in line with research and development of new and pioneering space technologies. So CubeSats are pretty much very small that you can just hold with your hand. It has a dimension of 10 by 10 and by 10 cubic centimeter. So these are the payloads and the specifications of the Maya 1. So it was released in 2018 aboard this ISS. The missions are the following, and it is still in orbit since 2018. So the Maya 1, this is an image of the release of the Maya 1 and all its accompanying CubeSats, which was developed by the other countries, which is part of the BIRDS project of the Kyushu or the Kyushu Institute of Technology in Japan. So together they launched with the Bhutan 1 and the UITM-SAT from Malaysia. Maya 1 is the first CubeSat developed by Filipino engineers by the 𝗘𝗟𝗘𝗥𝗓𝗄 microsat program. Following from the developments of Maya, we have the launch of Maya 2, which is also under the BIRDS project, which is the BIRDS 4. And then from that, we have developed many iterations of the Maya using the BIRDS bus architecture. We already launched the Maya 3 and Maya 4. This time, it is under the Stamina for Space program. And also today, which is currently in progress, is the developments of Maya 5 and Maya 6 cube satellites, which is under the Stamina for Space program in the Step Out project. So I want to quickly highlight the, which is the efforts of BIRDS project in releasing the open source information on the development of the CubeSats. So I would like to highly encourage those who are interested in development of cube satellites to check out and look into the open source release of the BIRDS project. So you can see them there, some digital textbooks that they have provided. So you can start your own development on cube satellites, and you can take it as part of your projects, or maybe in your research and development, or maybe you're doing your master's thesis or anything, if you are interested in line with space technology. So they have already provided the schematics, the fab design, so you can modify it as much as you want, and you can, I encourage everyone to check out this one. So enough of the developments and the satellites. So what I really want to impress in this presentation is to show you the value of space. So as Isaac Newton have mentioned, if I have seen further than others, it is by standing on the shoulder of giants. So I liken this one as to what we are doing with space technology is we are putting up satellites in the outer space as if they are standing on the shoulder of giants and seeing on, exploring on the things that we can pierce our eyes on and maybe find some value in it. So that's technically is the goal of 𝗘𝗟𝗘𝗥𝗓𝗄, and we are trying to find value in space exploration and where we are going to. So to show you some highlights on what are the values that we have already been found in space. So first, we have the natural and built environment monitoring. So I'm just going to highlight some of the points that we have, areas of value that we have taken from space. So it is in the monitoring of built-up areas. So what you can see in the image here is the development of the Boracay during the years of 2017 and 2018, if I am not mistaken. So you can see here the red as the urban areas and the green as the green areas. So you can use satellite images to monitor the built-up areas and assess the environment situation of islands of the Philippines. And another development is the disaster risk and management. So we can use satellite images and data to monitor our islands in terms of typhoons and then storms, or since our country is susceptible to disasters and earthquakes. So here is an example of Typhoon 𝗘𝗖𝗧𝗥𝗢𝗡, which was captured by our own Diwata 2 satellite. So we can see here an image of the eye, and this was captured by the wide field camera in 2019 during the onslaught of the Typhoon 𝗘𝗖𝗧𝗥𝗢𝗡. And next application is for defense and security. So we can use satellite data and the images that we capture from the satellite to monitor our infrastructures and to detect some damages on our defense, and of course to monitor our domain of awareness in terms of maritime. So we have here images of the reefs that are included in our country. So we have the Mischief Reef, Subi Reef, and the Fiery Cross Reef. This was captured in the year 2020 using the Novasar satellite, which is in use for the Philippines. And another values that we can find from space, of course, is the people that is part of the design and the development of the satellites. So we have a hands-on satellite development, hands-on data processing, validation, calibration, and of course the operations of the satellite, which is the establishments of ground stations in our country. So here's an image of the our step-up scholars that were the ones developing the Maya 3 and the Maya 4 CubeSat, as I have shown you earlier. Another value is the building of institutions or facilities that will cater to the development of space technology in our country. So we have educational facilities in UP. We have the Ulysses. This is the Ulysses building. And of course, designing local courseware and other institutions in the country. Another, of course, value is the linkages and partnerships that we made along the way, research collaborations, consortiums, and ground station networks, and of course, international partnerships and workshops with other spacefaring countries that are pursuing space research and development. So I just want to quick highlight also the consortium on the UNISEC. So this is a consortium on space education, which I believe Mindanao State University is also part of this UNISEC. So the school has already been part of the consortium. So I cannot highlight all of them, but there's really a lot of development on areas that we can find the value of space exploration. And in the interest of time, I cannot describe all of them. But what I want to impress to you is that PhilSA is building upon top of this, all these areas of expertise and developments that we have been into. And I want to end it with showing you the vision and the mission of PhilSA, contrary to others who would start with the mission and the why of their agency. What I want to impress to you is the goals of PhilSA, their vision, and what is their mission. And when going back to what I've said earlier, this is what I really envision when I say if I have seen further than others, it is by standing in the shoulder of giants. not standing literally on giants, but standing upon the developments and the achievements of the people that were before me. So working hand in hand together, fishing out the stars on space, exploring and finding value in it. So this is what it really means when we stand upon the shoulder of giants. So I guess that was quick. That was for the first part. So I hope I have given you an introduction and a briefer on what Philippine Space Agency is and what are the values that we find in space. So I hope you have your you have water or coffee today. So I encourage everyone to hydrate yourself, as I am also. As we go on to our next part, which is more on the technical side about spacecraft systems in engineering. Now, just a disclaimer, I'm not an expert on systems engineering, as I am an electronics engineer myself, but I've seen some developments and the processes that are included in systems engineering, especially in the development of spacecraft systems. So what I will be showing you today is to show you some of the important tools or processes that you could use in your own projects or developments, or maybe when you're doing your master's thesis or doctorate thesis, that may help you in your own research. So just to give a quick overview or outline of the spacecraft systems engineering. So I will be showing you a system view, what it's like to view the spacecraft in the eyes of the systems engineer, the scope of systems engineering. So what is the role of systems engineering in spacecraft development? And I will also present to you a tool that you could also use in your design, which is the V diagram. I will also present to you the typical project life cycle of spacecraft development, as well as an overview of what it is like to set up requirements when you are developing your own spacecraft satellite, and hopefully summarize to you what is all the learnings that you have garnered throughout this session, and impress to you what it is about systems engineering. So to start with, when we are developing something, when we are designing something, we usually look at the inner parts of working of the object that we are designing. So let's say a microchip, or we are developing a very complex microchip or an antenna, we usually look at the inner workings of it. But in the case of satellites, in the view of systems engineering, we look at it as a part of a bigger system, so a larger system. So, and of course, this system consists of components. So we have the satellite. We also have the ground segment, or what we call as the ground stations, that operate together with the satellite that we can use to communicate and to transfer data between the satellite. And another part or element of the system is, of course, the rocket or the launcher segment. So the rocket's purpose is to bring our satellite or our design into space in order to commission it and do its operations. So generally, these are the elements of a space mission, the total system combining the space segments, the launcher segment, and the ground segments. So in the view of a systems engineer, the systems engineer's role or purpose is to find an optimum process or way that he could efficiently develop the different parts of the space system and make it work together hand in hand with a methodological process. So to properly define these terms that I have given to you, so a system is made, or in this case, a spacecraft system is made of elements, whether it be human, machine, tools, parts, or maybe data or information. So in this case, we have our space satellite, we have our ground stations, we have the human operators that operate the ground station, we have the launchers or the rockets, we have the launch pads, and then we have the people that work together in the development of the spacecraft. So they all work together hand in hand to achieve specific objectives on their part, and then those specific objectives, they contribute to the overall mission, or they contribute to the high-level objective that is the role, or that is the goal of your system that you are developing. And the role of the systems engineer is to achieve an overall optimum. So it is optimization problem in which the mission objectives that are defined are realized efficiently in a process or a manner that is working hand in hand with the requirements that is set with the mission. So going deeper into systems engineering, so systems engineering is a process that we can use to develop something that is too complex to design. Specifically, in our case, it is the spacecraft satellite, and build it as a single monolithic entity. So monolithic meaning it is a single solid form entity that we are building. That later on we will segment into different parts and components, and we are to build. So usually a project starts with an idea, nebulous and ambiguous idea that we don't know yet the form of that idea, and then we conceptualize those ideas. We formulate information on what we really want, objectives of the idea that we want to achieve, what the system wants to do, and the requirements that it has to set. And systems engineering is taking that form, or this conceptualized form, taking it into shape, and then looking into the interactions of that object or system that you are developing to the external world. So you are looking at the interactions that it will be part of, and of course not just the external interactions that it will undergo, but of course the internal interaction between the subsystem that is composed of your satellite or the system that you are building or designing. So it is guiding the engineering process so that the system can be implemented, and of course to ensure that the needs of the project that you are building upon is met. So speaking of needs of the project, so in a typical project, the needs or the requirements are usually set by what we call as the stakeholders, or this is what we call the customer. They are the ones who made the project. They are also the ones that will assess the development of the project if it has met the things that they want to do. Another part of the project is of course the project management. So they are the ones who balance the risk, the ones who manage the schedule, and of course to take a look into the budgets and to make sure that everything is in line with the timeline and the development of the project. And then of course the important one as well is the engineering specialists, or scientists, or researchers that are the ones who are implementing the design and the development of your spacecraft or your the system that you are building. So they are the ones that needs the descriptions of the detailed descriptions of the things that they are building based upon the objectives that have been laid out upon by our customers or the stakeholders. And that's so strict descriptions as well, as to make sure na the design of our engineers they can be flexible with their design. So outside of all these three boxes that I've highlighted, everything that's outside the scope of them is the role of the systems engineering. So the role of the systems engineering is to interact with all of these three, the stakeholders, the project management, the engineers, and the specialists, in order to make sure that the project's requirements and objectives are met, and to make sure that the interaction between the three roles that are presented here are well in the optimum manner or method that the development is going through. as the project is developing. So in a typical process of development, I will show you a tool that you can use when developing a highly complex system. In this case, we have a spacecraft. So usually we start with project objectives that I have mentioned, which is based upon the needs of our stakeholders or customers. So we lay out the mission requirements and the specifications of what we need. So usually we still don't know how to form it. And then later on the stage, we formulate. So we do formulation, concept studies, trade studies, simulation that we can use to take our design into shape and to find some specifications that we could set upon our system. So we identify the system level requirements, the operations of our design as well. And then since our design is very complex, so the next stage would be to decompose and to segmentize all of the components of the system as to make sure that the subsystems or the subcomponents are designed and detailed up to the smallest possible components. So we set subsystem requirements or component requirements, and we detail out the designs that are in line, of course, with the requirements and objectives of the high-level requirements that I have mentioned earlier. And furthermore, we decompose the subsystems into minor components. So let's say, for example, you're building a chip. So you decompose the minor integrated circuits that you have to design, and then you decompose those circuits into integrated circuits into minor electronic chips or design schematics, and then you build the parts. So this is the components, decomposing the components and detailing out the design of these components. Now the next part is, of course, the design and implementation, and then it is followed by the assembly, integration, and test. So this is what we call AIT. So we assemble those components, minor components, and we integrate them. We test them based on the requirements that we have set. We verify those requirements using the testing design that we have implemented. And then next on the stage is we combine those minor components. So the small components, the small ICs, and then we integrate them into the subcomponents of our system. So this is what we call subsystem AIT, and assembly, integration, test, and then verify if the design meets the requirements that we have set earlier during the planning stage of our design system. Next is building up the whole system. So we are assembling or integrating the whole subcomponents into the one whole monolithic entity that it is our form or design that we have conceptualized during the early phases of the design. And then using the requirements that we have set, we then verify the results of the test with those requirements and check if we have met those requirements, and we properly document them. What are the trade-offs that we have gone throughout the development process? And then, of course, finally, we go to the operations or the assessment of if this is what we have been, if the concept that we have been envisioned earlier is what we really want. So this is the testing of the actual operations. So we call it the commissioning or the launch of the spacecraft into space. We have the operations. So the satellite will undergo its mission, so which is described by the mission requirements. And then, of course, the maintenance of the satellite as it is progressing with its mission. So this process is what we call the V diagram or the V model. So this is the entirety of the tool that I want to present to you about systems engineering. So the V diagram, so this is the whole simplified version of it. So we have the project definition phase. So we are defining the project on the left side. So we have the concept operations, the formulation, the establishment of requirements, the design architecture, and then the the decomposing of components, detailing out the components as well, and the specifications of those components. And then on the bottom stage, we have the implementation. So this is the development phase. We are building the satellite. We are checking out the circuits if it is on the right track. We are checking out the power if it is providing the actual power that we need. We are checking out the sensors. We are qualifying them if they are sensing the right measurement. We are checking out the actuators, or the ones that control the attitude of the satellite, if it is working hand in hand with the system. And then on the next part, we have the test and integration. So we have combining those components, little components, and then building up a sub-component, then test them, verify with the requirements that we set, and then building it, the bigger picture or the monolithic entity that we have conceptualized in the beginning, which is the system, and then we do the verification and then validation of the system, and then up to the operation and maintenance of the satellite that we are building. So this is the V model or the V diagram. It is one of the typical tools that are used when doing systems engineering. So it is very helpful, especially when we are developing a very complex system, since in this case, we are able to track the different errors that we may take along the way. Using those requirements, we can see if we are meeting the expectations of our stakeholders, and as well, it also reduces the time that we have to undergo when we are developing our system. So it is a very useful tool when developing complex systems. So of course, this model or tool is susceptible to problems, which is true for any model or project description. So usually you will encounter questions along the way. So you would ask, are these the right components? So you'd have to check the subcomponents if they are functional, if the logical requirements are met, if the physical requirements are also met. So do they meet the needs of the higher system? Are they compatible to each other? So these are the questions or the challenges of systems engineer when building a spacecraft. So, and then next up is, I want to lay out to you the whole process of the development stage in a timeline. So usually we start, as I mentioned, is we start with the stakeholder needs. So let's say we are building a spacecraft. So what does the stakeholder need? So let's say we want a satellite that captures images of agricultural farms in the Philippines, or in a specific island in the Philippines. So you lay out those requirements. So we need imaging satellite. So that's a requirement. We need a satellite that is able to pass the area of interest. We need it to be able to point to that area of interest. So we need a sensor, we need an actuator. We also need the power, of course, to power the system. We need solar panels to charge the batteries. So those are the things that we undergo when we specifying the needs of the stakeholders. Next up, we have the concept formulation and exploration. So we conceptualize based on those needs that we have identified from the stakeholders. So okay, we need these components. So what are these components? We detail them out, and then we conceptualize them. Next up, we have to set the requirements. So this is the nitty-gritty details of determining the requirements, document them. So the power should have this voltage. It should be able to supply this current. The sensors have to measure this. So those are example of requirements. And next part of the design is, of course, the analysis and formulation of the architecture of the system. So we have the function, what is the function of this sensor? So laying them out, functional, physical, and logical. So what are its function, and what is the physical structure or components of that system? What is its logical function, of course? And then you test them out or simulate them if they are working hand in hand together. And this is followed by the development stage. or the implementation of those I mentioned earlier. So we have determining of the low-level requirements. So we configure and we design and build the satellite on this stage. Next is the detailed design, and then we manufacture. This is the manufacturing, or if you're building your own, you can do the design and build, or you manufacture them from companies or any allied institutions that you go to. And then, of course, finally is the integration and test. So you verify your systems, you build them out together. So you assemble them, you integrate, you verify them with your requirements, you validate the system. If you undergo with test. So example of test in a satellite is environment test, radiation test, vibration test. So vibration test is to check if the satellite will still operate during lunch, because during lunch the vibrations is very severe. So you have to check your satellite if it is if it can withstand certain types of vibrations. So that is also part of the testing of spacecraft. So all of this is part of a timeline. This definitive timeline that you undergo when you're developing a satellite. So as I've laid out earlier, we have the concept, requirements, and then reviews, and then of course preliminary design. So in order to also to monitor the development of the system, we also conduct reviews, or this is what we call milestones. So milestones is a sort of stopping point. So okay, we have set our requirements, we stop there, and then we discuss with each other or with the team, with the management team, with the engineers, with the stakeholders. Okay, this is what we have built so far. We review this. So this is what we call the milestones or the reviews that we undergo during the development of the spacecraft. So this is an example of a typical project life cycle. So I will highlight here the kickoff. This is where you do the mission formulation requirements. So PDR, this is the preliminary design review. CDR, critical design review. So we sit down and we talk with stakeholders. This is what we have been building so far. We also have the flight readiness review. So we sit down and then talk, okay, the spacecraft is ready for flight. So this is what we have built so far. And then we go to the launch, commissioning, and then of course the end of life and the maintenance of the spacecraft. So this is the overview of a life cycle of a satellite system. So another part that is, I'm not going to discuss all the parts of the requirements, but I'm just going to show you the hierarchy of requirements that is part of the spacecraft system. So we usually start with mission objectives. So this is the objectives from the stakeholders, user requirements. So you usually have to undergo some constraints or issues, and then you build the mission requirements. So you base them out with the performance, the lifetime, the cost, of course, that is an important part when laying out. And you divide them into the segments that I mentioned earlier. We have the spacecraft segment, the ground segment, we have the launch segment. So you have to specify those requirements into those segments. And then during the development, you have to decompose the requirements of the system into subsystem requirements. So this is the subsystem requirements. We have the thermal structure, the power, the electronics, communications, attitude control, and there's a lot more that I cannot mention because of the interest of time. So this is just an overview of what are the typical subsystems of the spacecraft, but I'm not going to discuss them. But Floyd on the next session will discuss to you on the details of what these systems do, what it is that they are functions, the physical objects that are used when developing these subsystems as well. So I want to end my note on to summarize what we have learned so far in systems engineering. So really systems engineering is for developing very, very complex design. So we have simple designs. You might have to to make requirements, but it is not really necessary. But for complex design like spacecraft and satellite, you may have to undergo this type of process of laying out your requirements, doing the validation and verification processes. But there's a line in between, but it's ambiguous. So you can check out, or you can look at your projects. Let's say, for example, your research or master's thesis, and then check out, maybe I can apply, what if I can apply this type of model or development, and check, do I need requirements for this, or do I need the design architecture or something like that. So in summary, this is the overview of systems engineer, the roles, how does the systems engineer look at the spacecraft as a system and the interactions of a system, what are the project needs, who provides us with the objectives, the stakeholders, we have the project manager, we have the engineers. I've also shown you the tool that you can use, the V diagram, in your projects, maybe, or when you want to build your own spacecraft someday, hopefully. And of course, I've also laid out to you the building blocks of the requirements when you want to set your own requirements on your own projects. So yeah, that's it really for me for the systems engineering. I hope that you have learned from this session, and you have I have imparted to you some useful engineering tools, especially for us electronics engineers. So in a sense, we are all systems engineer in the small scale or in the bigger scale, depending on what projects we do. But the grand idea is that systems engineering is a way of, let's say, it's a way of engineering that we all can subscribe into, and then we can use it to further our developments in our projects. So yeah, that's it for me. I hope I'm not extending too much time, or I'm not sure. So I highly appreciate the time and the effort of inviting me to this webinar and session. So I hope I have also imparted to you some of the values of space and how it can contribute to the country itself, since it's a very controversial question, and why are we doing this space stuff when we can solve other problems or something like that. So yeah, that's it for me. Thank you. Maraming salamat, and kudos to everyone who is listening in the live and the Zoom. So yeah, if you have questions, you can.
Yeah. Yes, engineer. So thank you, engineer. And then, so everyone, let's join and let's send some virtual clap to our first speaker, Engineer Ibarra. You can send your virtual clap in the chat box, guys. All right, thank you so much, sir. And I am one of those people who are very fond of space science fiction films, and what you have just shared to us is such a very interesting topic. Actually, this is my first time to hear some space-related researches, and then in details, and then I don't know, it's my first exposure that some of our Filipino scientists and researchers are doing this kind of research. So, and that's why I'm very glad that I joined this webinar, and additional knowledge ika nga. So good thing this is a particular field that feels like something new to us. I don't know if you agree with me. If you agree with me, send some like button on the chat box. And so it feels great to learn something new, particularly on the satellite topic. So especially amidst this pandemic time. So thank you for sharing to us and helping us appreciate the value of space, as what you have shared, the quote from Isaac Newton: if I have something further than others, it is by standing on the shoulder of giants. So for those who are dreaming to work at NASA, you may start realizing that dream by maybe joining the Philippine Space Agency. Maybe we can ask Engineer Ibarra how we can join the team. If anyone here, is interested. So is that possible, sir?
Yes, that's possible.
All right. So now, without further ado, let's proceed to our question and answer portion. So I have here some questions from our dear participants. Let's have our first question for Engineer Ibarra. actually this the names are anonymous, so we can say who among the viewers or participants are asking this question. So first question is there any way that data from satellite can be accessed by the public? That's the first question.
Yeah, that's a very good question. I think one of the part of the issues that we encounter in PhilSci is to proliferate the uh, uh, well, the short answer is the space data is actually available. So you can check out the site of Philippine Space Agency, and of course all the projects that have been part of the space data mobilization, which is the 𝗫𝗫𝗄 and other projects as well. So space data is actually available. So you can check that out, check the website of the PhilSA, of course. I'm not sure if I can bring that up to you right now, but yes, it is available. You can check out, you can access them. One of the issues that we are going is to proliferate and to share that awareness that yes, data is actually available. Well, not all data, but some important parts of the data that you can use, especially with research, when you are doing research or when you are doing development in space technology or data or any imaging research that you want to use, especially when assessing images from our islands or any part of the country. So yes, you can actually. It is available.
All right. So for the next question.
Okay. Thank you, Engineer Ibarra. So we have here a question. I think it's from our students. The question is PhilSA open for internship? Parang gusto niya yata mag-internship sa PhilSA. Open po ba ang PhilSA? Are they accepting internship as of now?
As far as I know, I think wala pa so far. They're not currently looking for internships, although there are hindi PhilSA is not yet full in terms of the positions that have been identified for the whole space agency, since the space agency itself is just young still, so it was just established 2 years ago. So we have not yet filled out every position. So what we are actually doing right now, if you check out the Philippine Space Agencies, they are still hiring out some of those positions that are still missing in part. But yeah, we are looking forward to, like, in the future maybe add up some looking into internships or maybe assistance in terms of the research and development of space technology. So yes. Thank you.
Okay, thank you for answering, no, Engineer Ibarra. So sorry sa mga students natin ngayon. So hindi pa muna tumatanggap ang PhilSA for internship. And to follow up, we have here a question. Parang related lang din siya from the previous question. Are there any job opening in PhilSA for ECEs? Thank you for answering the question.
Yes, actually, one very amazing thing about being an EC is EC is a broad field, so you can go with communications, RF communications, you can go with power systems, you can go with electronics or structure as well, since most of the bus system of a spacecraft is it's full of wires, kumbaga. So EC is very much welcome in space technology. I think they are hiring for payload technology, so I'm not sure if still available, but they are looking out for especially EC for RF communications. There are also other fields that you might like to explore, like space mission or any other developments. But yes, they are very much welcome to EC engineers.
Okay, so ano pang hinihintay nyo? Apply na! So anyways, for the next question we have here, do stakeholders affect the decision-making, outcome, etc. of PMT in systems just like other projects? Or do they prefer outcome based on objectives only? Thanks. So that's the next question, engineer.
So it really depends on what stakeholders you are working with. So there are stakeholders from industries, there are stakeholders from government, especially there are also stakeholders from companies or manufacturers. So it would essentially depend on who is the stakeholder. So it depends on them in what liberty that you have in terms of making your requirements or checking out the outcomes. So it's also part of the systems engineer, for example, to lay out to them that, okay, the requirements are this and based from what you want. And then you have to show them that what are the reviews or what are the outcomes that they expect. And you can also maybe impart your knowledge on what are the reviews that be needed or developed, or the outcomes that you have to check during the development of your project. So it usually falls down on what institution or what type of stakeholders that you have. Some stakeholders like to look into the nitty details of the design or like the technical specifications. Some stakeholders just look into the overview. They don't look at the low level requirements, but they just look at the high level requirements or objectives, the outcomes from that, but they do not specify themselves with the circuits or the design or schematics. So yeah, that's a very good question. Thank you.
Okay, thank you, Engineer Ibarra. So we have another question here. It's come from a professor or student from a university. So the question goes is, how can a state university or colleges can access this data? I think it's particular to the data coming from the Philippine satellites. Is there a need for a MOA with PhilSA to access those data? Thank you again for answering this question.
Yep, that's a good question, but to be honest, I'm not sure how to lay that out. So it would depend on what type of data that you need. So there are satellites that we subscribe to. So not built by Filipino satellites, but satellites that we buy the data image into. So there are very good image data that we can look into. And there are also space data images that are free, or you can just check out in the space data archive that they have. But it would depend if what applications or what data image that you would use, since the images that we subscribe to from other satellites is paid, so it costs. So I'm not sure if you would need a MOA or an MOU for that, but maybe I can get back to you, or you can send me an email, or you can message PhilSA on that part. But maybe you can start by checking out the available images first, and then depending on what project you are building, you can check, oh, what images do I need? Do they have that images? And then set out if you have something, if you have specific bands or frequencies of spectral images that you need, you can tell the PhilSA, or maybe you can ask, do we need something for this? Or you can check out the archive if they have already that images. So yes, thank you.
Okay, thank you, engineer. So for the next question, we have here, where can I find, I mean this one. So what happens to the older cube or microsatellite if a new one is launched?
What happens to the previous? Well, cube satellites are just decommissioned during their lifetime. So decommission meaning they just fall out in the sky and then decompose into parts, and then they just die out. So what we are really looking forward to when building CubeSats is building upon the designs of, like for example, the Maya one, and then looking out into the design of it, and then develop more. So we developed the Maya 2, Maya 3, and Maya 4. So those CubeSats are just very small debris, and they just decompose into the atmosphere once they're done with their lifetime. So yes, those CubeSats will be decommissioned. CubeSats are only used for technology demonstration. So they are used for research into different payloads or technologies that we can add or you would like to explore during the satellites. And then microsats, on the other hand, is used for missions like Earth observation, communications maybe, like that. So yes, CubeSats are just for technology demonstration. So they usually are very small and low Earth orbit, so they just die out after doing the mission.
Okay, thank you so much, Engineer. I'm just curious, no? So maybe what's the estimate dimensions of a micro, or what you can say there, the cube that we're talking about here?
Cube, maybe I can. So
Yeah.
let's say this is a Rubik's cube. Almost this size. It's a 10 by 10 by 10 centimeters. So you can CubeSat you can just hold by your hand like this. So much bigger than this, pero you get the point. CubeSat you can just hold with your hand. So that's very, very small. So it's a very interesting question. Thank you.
Okay, thank you so much, sir. Now we got that overview. It's just that small. Okay, thank you. So for the last question.
Okay, for the last question, Engineer Ibarra. So we have here from Engineer Ilar. In what ways can a system engineering be applied to other electronics engineering fields aside from the space science and technology?
I guess it would depend on the project that you are working on. So as I have mentioned, the more complex your project is, the more it is, let's say, preferable to use a systems engineering approach when developing your project. So you would have to assess it by yourself to check if, do I need to set requirements for this type of project? Is the project too complex for me? Do I have to decompose it into components or subcomponents? So what's a good example? Let's say you are building a, let's say a microchip or a microelectronics design. You are doing a layout or design of your IC chip. Sometimes the details of your microelectronics design is composed of sub components or sub-circuits that you have to look into. So maybe you decompose them into parts or certain functions, so functional segmentation. So this part of the circuit is used for power monitoring. This part of the circuit is used for sensing. So this part of the circuit is used for communication system. So that's an example of how you could apply systems engineering when doing projects in electronics engineering. So you can segmentize them. Maybe you don't need to set up requirements. Maybe you just have to set specifications on those sub-blocks. So in a way, it's a broad approach, so different ways that you can use it. But altogether, it depends on what type of system that you are making. So the complexity, of course. And then, of course, I think one important part is the number of people working on the project as well, since you have to divide the workforce or the actions in terms of the development of the project. So yeah, that's a good question. Thank you.
Okay, so thank you, Engineer Ibarra, for all those insights that you have shared, especially informations about the satellites. And by the way, there's still a lot of questions here, but considering the time we have for this webinar, so what we're going to do is that we will be compiling all these questions, and then maybe we will send this to Engineer Ibarra for him to answer, and then maybe post the answers to the Facebook page, iecep Facebook page, and you can look at it there, the answers to your questions. So I think that will be all for our first topic. Thank you so much, Engineer Ibarra. That was really a wonderful learning experience from you. Now let's proceed with your quiz. So we will have our evaluation again. To those who really listen carefully about the topic that was just shared a while ago. So you may now answer your quiz for your evaluation. If you really understood the topic and you're learning, we will test about your learning on the topic. So here's the link that is posted on the screen, and you can also see the link, I think, in the chat box. Okay, so you may now start taking the quiz. God bless everyone and good luck. Okay, I think the link is already been forwarded sa chat box, no? Paki-check na lang. Okay. And let us know if there are problems in accessing the link so that we may know. Okay, by the way, you are just given 15 minutes to answer the quiz, and then we will be back here for the second topic for this afternoon. So make sure to finish the quiz at 15-minute time.
Okay, welcome back to our webinar this afternoon. So I hope everyone already finished the quiz and the evaluation for the first talk by Engineer Ibarra. So I hope na-perfect ninyo ang exam na binigay sa atin ni Engineer Ibarra, no? So before I introduce our second speaker, we would like to remind again our local member that the nomination for the new set of officers for iecep.iliganbaychapter is still open. We will close the nomination after the end of the talk of our second speaker. Once again, our local member, please check your email for the link for the nomination for the new sets of officer for the year 2022 for iecep-IBC. And now I will introduce our second speaker. He graduated cum laude with a degree BS Electronics Engineering from MSU IIT in the year 2018. He took his licensure exam for ECE and ECT on April 2019 and placed 7th among all the ECE board exam takers and 3rd place for the ECT. He worked as Science Research Specialist 1 in 𝗘𝗚𝗘𝗥𝗡𝗘 project under the Stamina for Space program at the University of the Philippines, Diliman from July 2019 to December 2020. He also worked as a Special Science Research Specialist in ASP project, still under Stamina for Space program at the University of the Philippines, Diliman. He is currently working on the Philippine Space Agency. Our second speaker specializes on satellite engineering, particularly on the onboard data handling engineering. Let's welcome our second speaker for this webinar, Engineer Floyd Ferrant to talk about Introduction to Multispectral Unit for Land Assessment, Satellites, and its Subsystem. Engineer Floyd, the virtual floor is now all yours.
Thank you so much, Sir Kevin. Can you hear me well?
Yes, loud and clear.
Okay. Let me just share my screen. So, okay. So, good afternoon, everyone. Thank you so much for the warm welcome, and I am honored to be your speaker for this afternoon. So, today I will be talking about the multispectral unit for land assessment, or also called as MULA satellite, and its subsystems, or the team composition in the building and development of this satellite. So a brief background about the space ecosystem. So the space ecosystem is somewhat segmented into 3 major parts, which is the upstream, downstream, and the end user. So for the upstream part, this is where satellites or any spacecraft are being developed, designed, also assembled, tested, and integrated. Also, as mentioned by Engineer Ibarra a while ago, there is a space segment and a ground segment for this, and also the operations and launch of the satellite is being included in the upstream. For the downstream, it is where when the satellite is already in orbit, it's already functioning, it takes pictures or images, right, of any area of interest that we would like, or it would pass by. So those images would be downloaded into the ground station, stored in high performance computing facility, and these images will be processed and will be processed, filtered, or any image processing will be implemented on the downstream or on the ground segment portion. Hence, the processed images will now be available for users or any partners, stakeholders that allow or ask or to access those data, and which is leads to the last part, which is the end users. This is the consumers, industry, can be academia as well, and defense and security, and any government institution or any institution that would like to use satellite data for their applications. So what is MULA? MULA is the multispectral unit for land assessment. Is an Earth observation satellite, just like Diwata 1 and Diwata 2. So mukhang, so sino yung nag-answer ng Diwata 1, Diwata 2 as Earth observation, may tama na kayo doon. So, Earth's observation means it is looking on the Earth, on the ground. It's not looking away from the Earth or looking in the deep space. So its main purpose is to capture areas, particularly for us, the Philippines, anywhere in the Philippines, so that we could assess different applications or different scenarios in that areas, especially during disasters, or it may be for our national security or even agriculture purposes. So, but the question is, why go to outer space just to capture images? So I just want to share that we are fond of somewhat or fascinated with a big picture, right? For example, we are traveling, then we have those drones with us, and when we try to launch our drones and to see the wider view or wider perspective or a certain location, we can just appreciate it, and we're fascinated of the wider picture that we are looking. And same thought with that, satellites as well could give us a much more larger view, so that we could easily assess situations, assess interests of us for different applications. So MULA also could cover the Philippines in under 5 minutes at 600 kilometers sun synchronous orbit. So there are different kinds of orbit that I will discuss in the next slide. So this 4 is different kinds of orbit, and the first orbit is the geosynchronous orbit. This is around 35,000 kilometers above the Earth. It is this blue ellipse here. So this is the somewhat it functions where in geosynchronous orbit, the satellites are in match with the rotation of the Earth. So, for example, we have a satellite in geosynchronous orbit for our weather stations. So when the Earth revolves, it matches those it matches with the revolutions of Earth. So it's always up in the sky, directed to Earth. So that's why its main purpose is communication and weather satellites, because we want that our communication weather satellites are seeing the Philippines 24/7. So the next type of orbit is the MULA orbit, which is the around 39,000 kilometers. So this is also for communication satellites, but its main purpose is on the Arctic region, the continents near the South Pole and North Pole. So this yellow orbit here. Third is the medium Earth orbit, which is the purple. It's around 2,000 to 35,000 above the Earth, and its main applications would be on navigation satellites like GPS, GNSS constellations. So we are using our phones right now or these services in our daily lives right now. And lastly is the low Earth orbit, which is the future home of MULA. It's around 2,000 kilometers above the Earth. So in LEO or low Earth orbit, it is the orbit that is much closer compared of the other orbits. Hence, launching or the launch costs to this orbit are much cheaper compared to launching satellites on those further orbits. That's why MULA will be somewhat launched and commissioned at orbit in succeeding year. So this is where also other Earth observation satellites in like Diwata 1, Diwata 2, and even the Maya satellites that was introduced by Engineer Kenneth a while ago. So how big is MULA? In comparison to the nanosat that Kenneth described, the nanosat is this Maya 1, for example, which is around 0.1 or 10 centimeters by 10 centimeter and 10 centimeter, and around 1 kilogram of weight. So it's much, you can, as Kenneth mentioned, you can hold it by your hand, and it's like just cube, a Rubik's cube, slightly bigger than a Rubik's cube. The next type is the Diwata one, which is around 0.35 by 0.55 by 0.55 meters, the dimension of it, and around 50 kilograms only. So Diwata 1 and Diwata 2, almost the same dimensions and weight. So you can compare it to just a balikbayan box in your home. So hindi siya ganun kaliit, pero hindi rin naman siya ganun kalaki. So and in our case now, MULA, it is much larger than the Diwata 1, Diwata 2, and it's slightly bigger as well, which is around 130 kilograms. So if Diwata 1 is like a balikbayan box, MULA is like a ref in your house. So or you can compare it, but compared to those satellites that are traditional, and it is a small satellite, or what we call microsatellite. So this is me, approximately 1.7 meters and approximately 72 kilograms. I am taller than MULA, but MULA is somewhat bigger in weight. And compare to those traditional satellites, which is more of the orbited in the geosynchronous orbit. It is much MULA is just a tiny portion of those traditional satellites that we have. So in terms of cost, development time, it is much cheaper and it's much faster to build a microsatellite or small satellite than those traditional satellites. That's why the trend of satellites right now are on focus on these small satellites due to their cheaper development costs, and as well as faster development time. So how can MULA operate in space? So MULA, just like any other satellite, will rely only on battery power, and these batteries are charged through solar panels while in orbit. And so in this slide, the one you somewhat I describe it as a wing of MULA. This is where solar panels are placed into, as well as on the sides of the satellite, to be able to store and to use the power from solar energy. And MULA is expected to last in space for at least 5 years. So just like Diwata 2, 5 years ang expected lifespan in MULA. And as we compare MULA with our home appliances, the LED bulb consumes 10 watt, our TV is 60 watt, and our fans, and also our gaming laptop is 160 watts. MULA is also just around that, because most of the components used in MULA is just commercial off-the-shelf components as well, or doesn't draw much power, since it's also enclosed in a small satellite or a microsatellite. So the applications of MULA, first is on the agriculture aspect for our food security. So MULA could look at the crops on the farms, and it could assess how much we can harvest for the season and where can we plant to potentially increase our yield. So in this picture is the rice field in China, where the greens are where dense vegetation, or where is ideally we want to plant our crops, compared to those on red, on orange. This is captured by Diwata 2 high precision camera. So the next part, the next application of MULA is also can record evolution of infrastructure and public spaces. So for example, a disaster or typhoon was passed by the Philippines. So we could also command our satellites to capture an image and on those areas of interest that was that where the typhoon passed along. So we could assess also the differences of the place or the image before and after the disaster. So we could also prepare, or the disaster risk management would also know how to approach the situation. So apart from the disaster, we could also check environmental effects on industrial activities. So on the lower, in this part, is a quarrying site in Antipolo, Rizal. So the first picture on the top is captured March 2016, and 3 years after, March 21, you can see that it has affected our environment in terms of the mining procedures. So we could easily compare different time or different images, same place but different time. So, and lastly, we could also monitor status and progress of infrastructure projects at remote locations. So on the upper part is the access road, which is captured in 2018, and 8 months later, after completion of the infrastructure project, it could clearly be seen in the space. And we could assess also, this is helpful for the partner government institution as well to assess completion, or to assess the projects, the quality of the project and how they progress. And last application of MULA is also, it could help us with our national security by giving us situational awareness by the detection of maritime vessels within satellite range and detection of aircrafts within satellite range. MULA has these payloads called automatic ADSB, automatic. It's for tracking maritime vessels, and AIS, or automatic identification system, where it tracks aircrafts when MULA pass by the Philippines. So this is helpful with our current issues with the West Philippine Sea, and to just monitor the shipping vessels around this area. Also for securities regarding the aircraft. So how can MULA do these things? So the main, somewhat we call payload, or the main camera that MULA is equipped is called a true color imager. So a true color imager is just somewhat our cameras in our cell phone, but it's a much larger camera, and it is capable of capturing high medium resolution in orbit. So it has 9 unique spectral bands. When I talk about spectral bands, it is different, somewhat. It captures images with the different wavelengths, so that during the processing of these images, we could filter out which through these bands. So for different applications. So for example, the aerosol or coastal blue band, mainly for air quality. So we could assess the air quality on a certain location. The blue, green, red band are the bands very important on every image to have this true color. The red edge bands are mainly for agriculture applications. So we could assess those soils which has dense, we could yield dense crops, and also the NIR, near infrared band, could be useful in those applications. So also the true color imager could scan the Earth 120 kilometers across. So when MULA passed by the Philippines, it could capture this area of interest during its pass. So it's a much wider area during a single pass. So it's very useful to assess the image. And it also could provide images with 5-meter resolution, which is the ground sampling distance. So a background on, let me share again. So a background on ground sampling distance. So different satellites would have different ground sampling distance. So this it somewhat separates by this specification: 30 meters, 20 meters, 10 meters, and for IRSIC, this is 5 meters, just like MULA. So as you can see, the ground sampling distance means that for every pixel that the image would capture, this is somewhat the range or of the range where it could clearly be involved in a 1 pixel. So for example, for a 30 meters, only 30 meters in this on 30 meters by 30 meters for 1 pixel. So the lesser the GSD or ground sampling distance, the clearer the picture, because it's every pixel is dedicated to a much smaller distance. That's why it could process a highly resolution image. So also, as I mentioned, MULA has, apart from this true color imager, MULA also has the ADS-B, automatic dependent surveillance broadcast, which is to track aircraft, and also AIS to shift. So also, MULA will be capable of simultaneous capture and download. So when MULA passes by our ground stations, it could capture an image of the Earth. At the same time, it could download those data to our respective ground receiving stations. So the question, also one question is, why not just use free data or buy from other satellites? So we are currently using, and me myself are very fond of using Google Maps when I travel or when I go into a place that I'm not familiar with as well. Also, there's Mapbox, but these free mapping applications don't provide us regular updates. Also, there are also free data sources from government satellites, from foreign government satellites, just like Landsat and Sentinel, but they are not exactly fit our purpose, because the main mission of those satellites is for their own country. So that's why it's good to have our own satellite, our own sovereign satellite for the Philippines, so we could command it on our own, and especially when there is times of disasters that we want image data urgently, so we could command the satellite when it's passed on those specific areas. So it could have much faster application for us, the Philippines, and for its users. So the total on this right part is the total investment cost in building also MULA. So it covers the know-how training from the foreign satellite partner, also the licenses, and one of the key features here is our license to rebuild MULA. Once it's done, we could use this platform to build more satellites in the future. Also, it is the satellite cost for the development, testing, and every activity covered, and also for the launch and early operation costs. The total of investment for this is 1.7 billion, and it's a huge amount of budget. But it has a very big or return of investment for us, not just on the value of money, but also for the Filipino people or the Filipino engineers that been trained, and those engineers would also train more Filipino engineers, so that we could have a more progressive progressive state or progressive progress, it will be progressive in space technology in Philippines, and we could somewhat compete, or not just in place with other developing countries or countries that are experts already on space technology. So the investment gains were computed based on the cost of medium resolution data, which is 64 pesos per square kilometers based on rapid eye image data, and the total ideal coverage per day of MULA, which is 73,660 square kilometers. So this is just 58% of the whole Philippine specific economic zone, because we not considered 100%, since some of the images would have clouds, hence it's not very useful for it. So only 58% were allotted and per day. So computing the total would be just product of this times the number of days and the 5 years, which is the expected lifespan of MULA. So, but don't we have this capability already? So 𝗬𝗧-2 has its high precision telescope, which also has the same ground sampling distance, 5-meter resolution. But let me share this video. So the red portion here is somewhat the area of interest, where that 𝗬𝗧-2 with its high precision camera could capture. So this tiny square here. So compared to MULA, which is the bigger, so the bigger rectangle here, this is how MULA could capture in one single pass. So it could capture a much wider region with the same resolution that what 𝗬𝗧-2 has, with a given smaller area. So it's a much somewhat better compared to 𝗬𝗧 with a wide range. So let me share to you the somewhat the progress of MULA right now. So what ano na yung parang current state ni MULA since it began developing. So since just a background, MULA is not yet finished right now. It's under development, and also expected to be launched by 2024, hopefully, if the budget would be granted. So this is the typical phase of the project. Every somewhat agency has their own project implementation, but this is somewhat one of the most generic or typical phases that the satellite development project would undergo. Start with the bid phase, where you somewhat ask the stakeholders or ask the users what kind of data would they want to achieve, what for their applications. Also, this is where the initial talks between the end users and the developers or the satellite providers would take place. So it is concluded by a kick-off event, or where after bid phase, when the requirements or the mission goals or the missions for the satellite or for those projects would already be approved by both parties. So it would project kickoff would take place, where the engineers to develop this would be introduced. The mission statements and mission requirements would be announced as well. So this is technically the start of the satellite development process. So after kickoff, there is some preliminary design activities wherein the initial design of the satellite would be established. Also, the per subsystem heritage, or what we call what could we use from before before, or what components or modules could be reused from the proven and already launched satellites that are which are somewhat important or could be used for this project. So this is where it is being identified in preliminary design, and also the concept of operation or ConOps was also established. So it was concluded by the PDR, and also detailed design would take place after, wherein those initial design would be more dig deep. So more low level design would be conducted. Fault detection and isolation recovery would somewhat be set, so that if failure or errors or will be encountered, there are solutions to be implemented. So this during the detailed design phase, everything from the subsystems would be defined on a much lower level. It would be completed by a critical design review, or CDR. And after CDR, each module or each subsystems would test their satellites, and if their own modules level testing would pass, it would be recommended to be assembled, integrated, and tested as a whole system. So ARR, or assembly readiness review, would conclude those phase, and also test readiness. This is where every module testing or fault detection, isolation, recovery testing would take place, and it would be concluded by test readiness review. So when every module or unit has been tested and passed the PRR, it is somewhat will undergo a more extensive testing, especially as a whole system where it is being integrated. Different modules are being integrated into a single satellite. This is where environment, vacuum and thermal testing would take place. Spacecraft level testing or system end-to-end tests would take place, and also launch campaign or planning for launch would also take place. And it should be concluded on a flight readiness review. So after flight readiness review, and if all of the modules or subsystems and the satellite as whole pass this review, it is ready to be launched. So pre-launch activities would take place. So we will find launch providers. Also on small satellites, we do not somewhat for one rocket for one satellite. It is not the case, because on a larger satellite, that's what happens, right? Only one rocket, only one satellite are included in one rocket. So for small satellites, there are terms called piggy banking, wherein one satellite or multiple satellites are being somewhat sama-sama sila into a single rocket, and when they launch all together and when reach space, they just somewhat separates from the rocket and go to their existing orbit. So in that sense, the satellite developers would save money, since they are somewhat ride sharing in a single rocket, and would decrease the cost of launch for the satellite. So when the rocket or when the satellite has been launched, in this phase, it will go commissioning phase, wherein the satellite is somewhat stabilizing itself in its orbit, which is our case, the low Earth orbit, and it is the initial operations, or somewhat it's until it is somewhat settled on its orbit. That's where the commissioning would end. It is reviewed in an in-orbit commissioning review. And once after the in-orbit commissioning review, this is where we could use the satellite now to our day-to-day operations, and it could be commanded now. If luckily during the launch nothing was somewhat damaged, or the satellite was intact and still functionable. So we could use the satellite once it settled its orbit and it's somewhat its status is okay, or no damage has been done. So in that sense, from these phases, we are still on the PDR. The phase 1 of MULA ended on PDR. So the kickoff started on December 2020, and the PDR takes place on August 2021. So more details for this this slide. So project kickoff, which takes place on December 2020, were attended by representatives from UP Diliman, Philippine Space Agency, and the OST. This is where the baseline technical design and the contract for phase 1 was presented. And also the engineers, Filipino engineers, to undergo training at SSTL UK, or Surrey Satellite Technology Limited, is being introduced to the stakeholders, or to these representatives. So after kickoff, there is some activities, preliminary design activities, which was concluded by this event, the QSR, Qualification Status Review, which was held on April 2021. So it increased confidence in satellite design by presenting components with flight heritage. So this is what I mentioned a while ago, that not all, in every satellite design, not all modules or subsystems are newly developed. So especially with satellites that have somewhat great performance, or somewhat reliable performance in space, those modules used in it would highly be recommended to be reused on a new development or a new satellite, so to have more confidence or more reliability on our design. And also there is an satellite technology training course to 42 Filipino representatives. Also, this is where the Filipino engineers was deployed into the UK for hands-on training. So among the engineers, not all was deployed due to some travel restrictions. So but nonetheless, the training was still continued, and some conducted remote training with their SSTL mentors. And the next milestone is the preliminary design review, which is held on August 2021. This is where a detailed design of the satellite subsystems, each subsystems, and it's somewhat if it met the satellite mission, or the detailed design meets the set requirements for the satellite mission. Also, wrap-up consultation for in-country facilities, and also concluded the phase 1 hands-on training of Filipino engineers in the UK. So this is where the preliminary design review, and also the phase 1, which is this part of the MULA satellite development, concluded. So right now, after that, Filipino engineers went back from UK to the Philippines to conduct some training also, and know-how transfer to other institutions, and until right now. So we are expecting the phase 2 to start tentatively. This is the activities for phase 2. So no date yet, but we are eyeing on 2023 if the budget permits to continue the satellite development. So what's up ahead? The phase 2 kickoff, which will start here. The critical design review, also the IRR, or integration readiness review, the test readiness review, and also the flight readiness review. And also hopefully by September of 2024, if this timeline proceeds, MULA could be launched and could be usable in space. So I guess for this part, slides lang muna tayo ng konti. And if you have any questions, just feel free to somewhat chat it or send it in the link. And yun. And I'll just take a somewhat quick break to rehydrate. And also, okay, then. So I guess I could proceed now. So the second part is the MULA subsystems and also the team composition. So for the subsystems, I will just give an overview of each subsystems and also the background of the engineers being somewhat responsible for that subsystem. So it could also emphasize with the main team for this event, electronics engineers in space technology. So as ECE, how could we contribute to different subsystems of MULA or any satellite development that we want? So let me start with the project management. This is not a subsystem, but it is a very important and relevant role in satellite development process. So he is the one to oversee the completion and the activities of this phase. Also, he would be the one responsible in assessing the risks occurring during each of these events or each of these activities, and would likely to somewhat resolve or manage how to resolve those risks or lower that risk so that the project would continue smoothly or with low risk. And there's three words are the somewhat sacred for the project manager: timeline, budget, and quality. So the project manager ensures that the project is delivered on time. Also, the budget would be somewhat spent para sulit, and also the budget for each phase or for each subsystems would be met or with those cost-effective solutions, and also the quality without decreasing the quality of the project or of the activities that being conducted. So our project manager is Engineer Janlo Rabrador. He is an ECE or electrical and electronics engineer in UP Diliman, and also he took a master's in aerospace engineering. So that's his tasks are what I mentioned a while ago. So the next is the systems engineering. So an extensive background was discussed by Kenneth while in the first session. So I will just somewhat summarize or quick overview or recap. So the systems engineer is also the technical lead of the team. So he must know, or he or she must be familiar or must be knowledgeable on each aspect of this or in each subsystems. So he or she is the one responsible and the overall engineering design of the satellite, or how would it be. There are what we call data budget, link budget that the systems engineer would prepare so that the satellite would operate in an optimum performance based and it also ensures that the mission objectives or the requirements are met efficiently. So starts with the systems engineering management plan, concept of operations, system level requirements. Now the system level requirements would be boiled down to subsystem requirements. The subsystem requirements are responsibility of the subsystem leads in defining that, and also the component detail design are responsibility of the subsystem leads. And also the hardware and software implementation or the coding and test are on the bottom of the V. And once this is what we call the development is somewhat finished, it would go to verification and testing by part if the results meets the expectations or the requirements set for the components, the subsystems, and the system as a whole. So the systems engineer and also the technical lead is Dr. Julian Benatao. So she graduated graduated Electronics and Communications Engineering in UP Diliman as well, and also took Doctor of Philosophy of Aerospace Engineering. So this is her main task: perform spacecraft mission analysis and create systems budget, design satellite concept and operation, and ensure that satellite works as expected when launched in orbit. So I would like to ask in the background lang to somewhat count the number of ECE on the team. So you could somehow relate to or choose as well which subsystem piqued your interest or would like to know more if you want to be involved in satellite technology or space technology. So you could learn or focus on which aspects or which skills or field you want to pursue. Also, we have the thermal radiation and propulsion subsystem. So the TRP is somewhat focused on the thermal aspect of the satellite. If all of the satellite could fully functional while in space given its wide range of temperature changes from very cold to very hot in a matter of seconds. So the thermal engineer must ensure that all of the components would still function properly, given that somewhat scenario. Also, the thermal engineer is also responsible on the radiation analysis, or must also check the radiation capabilities of the components, the modules, if they can survive radiations in space. And also propulsion subsystem, which is mainly focused on thrusters and propellants. This is the propulsion somewhat helps the satellite to reposition itself in orbit, and also could be useful as well in the decommissioning phase, or when the satellite reaches its end of life. The propulsion subsystem or system would help the satellite to deorbit itself from its orbit down back to the Earth atmosphere. So the TRP engineer is Nathan Rosimo, and he graduated Materials Engineering in UP Diliman, and his tasks are what I mentioned a while ago. Next is the mechanical subsystem. So if some of you I know all of us have subjects in ME or somewhat structures, right? So the main responsibility of the mechanical engineer is to develop the satellite bus frame, or the structure of the satellite where the components could hold into, and also the enclosure of the satellite modules, and also the structure of the satellite itself on its own. So in this picture is a somewhat a nano satellite or cube satellite frame, somewhat conducted with additive manufacturing. So some materials as well are used, such as aluminum or steel, or there are research as well of using 3D printing structures in space, but that's on another somewhat topic. Also, they are responsible on the wire harness and mechanisms. Since as we all know, in our projects, right, there are multiple wires that we encountered. So from just simply building as a small module or electronic device, there are breadboards, di ba? Maraming wires na nakahang, kahit saan na napunta, tapos mahirapan na tayong parang i-debug siya kasi pag nasira or there are things na hindi na nagfa-function, yun, mahirap na kasi ang daming wires na nakaano. So cable management, that's right. So the mechanical engineer is also responsible on these things, so that it could fit on the satellite given its minimal space, right? So right, that's it for the mechanical, and it's divided into two parts: the design and analysis. So the mechanical design is the one responsible on the design of the structure, while the mechanical analysis conducts simulations, finite element analysis on these structures. So Gabriel Mabini is the mechanical design. He graduated mechanical engineering in UP Diliman. And the mechanical analysis engineer is 𝗘𝗚𝗚𝗚𝗏𝗺. He graduated mechanical engineering in UP Diliman and aerospace engineering in Tohoku University, Japan. So yeah, he conducted the mechanical analysis conducts simulations to ensure components survive dynamic environments during rocket launch and harsh conditions in space. So the next subsystem would be the attitude and orbit control system. So this is where Mr. Ibarra is focused on. And most the products here are actuators, reaction wheels, and magnetorquers. As we all know, we are familiar with our actuators. Sino ba yung mga naka-experience mag-develop ng sumobot in their undergrad? So we have those motors, right, that we controls. Also, magnetorquers are passive, somewhat actuators as well. And also, apart from this, they are responsible on the sensors in the satellite to somehow determine the attitude. The attitude means somewhat the orientation of satellite in orbit, if it tumbles, or if may just stable ba siya habang nag-orbit siya. And also orbit control, if this is where somewhat, if the satellite tumbles in space, the orbit control system would somewhat process or somewhat make the satellite somewhat stable by addressing those tumbling with the help of these sensors, which is a star tracker, magnetometer, gyroscope, also GNSS or GPS receiver and flash antenna, and sun aspect sensor. So these are important because we want to know where our satellite is currently in orbit, right? Because hindi natin alam kung nag-orbit pa ba siya, buhay pa ba siya, or saan part na siya ng orbit or ng Earth banda. So these sensors would help us determine those, so we can detect or somewhat manage the status of our satellite. So it is divided into two as well, the hardware and software. The AOCS hardware and GPS engineer is Manuel de los Jr. He graduated ECE in UP Diliman and also took up masters of science in mechanical engineering in National University of Singapore. So he manages the hardware part of the AOCS and calibrating the sensors, actuators, and also do some GPS handling and the like. So the other part is AOCS software, which is our engineer Kenneth Ibarra, our speaker a while ago. So he's more focused on the software part, software development part of the AOCS. So programming is one of the somewhat skills that he is capitalizing by programming by programming those integration with the AOCS hardware that I presented a while ago. So he is a graduate of MSc-IT as well as an ECE. So next is the power systems. So this could go with both electrical and electronics. If you have a background on power electronics as well, you could be the one handling the power systems. But most of the modules in it are power distribution and battery charging modules, batteries, battery handling, and also the solar cells. So it's the one responsible on the power system management of the satellite. So our power systems engineer is Engineer Daniel Fadi Rahayel. He is a graduate of electrical engineering in UP Diliman and also a master's of MS in electrical engineering UP Diliman. So his tasks are what I mentioned earlier. So next is the communication subsystem. So in IIT, there are a track or a lab for RF, right? So we could relate in the subsystem as well. So the main contribution of ECE in this part are antennas, doing the transceivers, software-defined radios in that could be included in the satellite as well. So it's not an easy task doing the communications or the RF links because due to somewhat power issues, also the limited power in the satellites, so our RF or communication engineer, so we are using S and X band for MULA. So he is Dr. 𝗘𝗟𝗘𝗖𝗧𝗥𝗢𝗡, a graduate of ECE in UP Diliman, also an MS in electrical engineering in UP Diliman, and also a PhD in space engineering in Kyushu Institute of Technology. So he conducts link budget analysis for the satellite communication subsystems, antenna modeling, simulation, and testing, and also support activities pertaining to S and X band subsystem and secondary payloads, the AIS and ADS-B, which are used to detect ships and aircraft. And next subsystem is the payload subsystem. It was divided into two, the optics and optomechanics, where the optics are assigned on developing the lenses and the camera without the image sensor, is that what I called it. And the payload engineer must have background on optics, optical engineering, and the like. And the other part is the optoelectronics or front-end electronics. This is where the in this somewhat baffle or barrel, this somewhat camera without the image sensor. The image sensor would be placed on the end of it, so it would be entirely a camera or an imager that with our proper that could be used in the satellite. So the true color imager consists of this part and the image sensor with the FPGA board or FPGA chip for processing, image processing, and onboard processes which pertain to image sensor. So the payload engineer is for optics and optomechanics is Dr. Paul Leonard Achong Hilario, graduate of applied physics in UP Diliman, also MS in physics and PhD in physics in UP Diliman as well. So he is the one responsible in building the lenses or the payload, and his partner Paul Nababos, front-end electronics, is the one responsible in somewhat the development of the image sensor and the FPGA blocks that will be used for the image processing onboard. So it could be from a pixel in the image sensor. It could be an entire image. It could be somewhat segmented into an entire image that could be downloaded and used and downloaded to the station and used by end users. So Paul is a graduate of electronics engineering in University of San Carlos, and he is assigned on the firmware design and development of the payload electronics and conduct testing procedures and integration of the FEE with optical payload. So next is the onboard data handling subsystem, which this is somewhat they call the brain or of the subsystem, because somewhat it somewhat processes the commands from the ground station and somewhat passes those commands to specific subsystems depending on which mission is or which command is that or subsystem is that command for. So it's divided into two: an onboard computer and processors, and also the data handling and storage units. So the onboard computers are what we call I would say the main processors, or the main somewhat microcontroller, or it could be a microcontroller, it could be an FPGA with an system on chip with a processor embedded into it. But its main purpose is to just process the commands received from ground stations, gather status data from different subsystems and components to so that to assess if if the satellite or the components of the satellites are have somewhat errors or some we call this are functioning properly, and this data are being managed and passed down to the ground station for assessment. And for the data handling units, this is focused on the image or the data part. Or after the processing from the front-end electronics, the data or image data being produced is being passed to the data handling unit for storage, for memory handling, or because the data handling unit have much larger memory capability than the front-end electronics. So this is where all the data are being stored to, and this data are being downloaded when the ground station requests to download data, or there's an opportunity to downlink the data when a satellite passes the Philippines or any ground station that we have. So yours truly, this is a self-serving somewhat slide. I am the onboard data handling engineer, and I graduated electronics engineering in MSU IIT. So I ensure reliable data transfer from the payload or the front-end electronics to the onboard memory, and also to the ground station when it's time to downlink or download the data. Also ensures appropriate onboard communications between data handling subsystem and other subsystems. This is where the command processing or command forwarding takes into place, and also assigned on the OBDH hardware or somewhat firmware development. This is the firmware or gateware is somewhat the development of FPGA blocks in the onboard computer or any microcontrollers. So I have a partner as well, which is focused on the flight software part. He is Joash Rodriguez, graduated Bachelor of Science in Electronics and Communication Engineering in UP Diliman, and also Master of Engineering in Electrical Engineering in UP Diliman. So since I am assigned on the hardware and the firmware or gateway part, he is mainly responsible on the onboard software part, or the flight software that we call to for the onboard computers and onboard data handling system. So next is the ground segment. So all the previous members are somewhat assigned on the upstream, as I mentioned in the first page, wherein the somewhat satellite itself. And the second part, these three members are assigned on the downstream or the ground segment part of the satellite. So the first is the ground segment system. This is 𝗃𝗃, as you can see, our Philippine Earth data resource observation, or just somewhat the ground receiving station for this is mainly for Diwata and Diwata satellite. And for MULA, we are targeting to use the ground receiving station in Davao that was somewhat recently inaugurated, I think. So since parang konti pa lang yung users or yung use case ng sa Davao. So this is located in Quezon City, this 𝗃𝗃 facility, and also has the control room, which is commanded by the satellite operation engineer when downloading, uplinking the commands or requesting image data from the satellite. So ito yung mga nakikita sa control room. So the ground segment engineer is assigned on somewhat manages or facilitating in the development of this, from the antenna to receiving this into the control room and the entire process of the ground segment. So our ground segment engineer is Engineer 𝗘𝗟𝗘𝗥𝗡𝗖𝗧𝗥𝗢𝗡. She's a graduate of Electronics Engineering in UP Diliman and Masters of Engineering, Science in Electrical Engineering in UP Diliman. So she is assigned on the full aspect of the ground segment. And the next is the satellite operations, which is assigned on the day-to-day operations of the satellite. So 𝗃𝗃 means Philippine Earth Data Resource and Observation Center, control room. So this is where the satellite operation engineer would somehow, he's the one deciding which command to to upload, or which area of interest are we like to capture in this part, or when the satellite passes the Philippines. So the satellite operations decides that, and he is the one conducting that process in that uploading the commands to the satellite. So the spacecraft operations engineer is 𝗘𝗟𝗘𝗘𝗥𝗓𝗚𝗔. So she is a graduate of applied physics and a master of physics in UP Diliman. So her role are manage the day-to-day operations of the satellite, command down, uplink. There are commands that are real-time executed, and there are also scheduled commands. Payload image data download. She's the one requesting the satellite to download the stored images in it, and also assessment of the telemetry data and status. So also she decides where the area of interest for image capture during a satellite task. And lastly, last but not the least, is the downstream services. So as I've said, the downstream part does not end when receiving the data. The downstream, the data, hindi lang siya parang ma-store into somewhat of memory facility in the ground, but this data must be used by several users, right? It could be students, it could be government institutions, or private institutions as well. So the downstream services engineer ensures that these data are being processed or somewhat into somewhat a more higher resolution. So this data can be available to anyone, I guess, since we are a government agency. So our somewhat products must be for all Filipino that are interested and may have use case of this data. So the downstream services also ensures or develop this space.gov.ph space data dashboard, which is mainly used for COVID-19 tracking. But also there are a lot other parts that could be, or other applications that could be assessed in this data. So you can visit this site for more information. Also, possible applications as well could be traffic monitoring and also changes in air quality. So our downstream services engineer is Engineer Romer Christy Aranas. He is a graduate of geodetic engineering and also master's MS in geomatics engineering in major in informatics in UP Diliman. So he ensures mission is widely utilized in the country by focusing on Filipino end user engagement, and also plans natural outreach and distribution policies for image requests and product generation. So if you want to access the data or you want interested, you can message info.philsa. Later I give you the email, and they will direct it to Sir RK's division, so that you could be helped how you can access the data and help end user in creating meaningful products from satellite image. So overall, that is the 16 somewhat MULA engineers, and so I just want to relate it with this team, today's team. So no matter what your engineering background is, you are somewhat capable of being part of any of those subsystems, right? If one of those subsystems pique your interest and somewhat inspired you to be part, so just focus on the skills, on different skills that are required, and developing those skills so that somewhere maybe in the future there's an opportunity to contribute to space technology, or when you graduate, for those students, when you graduate, you could apply to not just PhilSA but other somewhat space related companies or institutions in the Philippines. So these are the required skills. This is given by the foreign partner when they choose the different engineers, if they have this background. So project management, systems engineering, thermal TRP, mechanical engineering fluid systems design, for payload, optical engineering or mechanical, for payload front-end electronics, optical engineering or data and analog electronics, for mechanical design and analysis, basically mechanical engineering. For power, it could be analog electronics or electrical engineering, RF electronics, onboard data handling, digital electronics, flight software, software engineering, AOCS hardware, electronics engineering as a whole, since yes, it dwells with those sensors, right? AOCS software engineering or physics, ground segment, software engineering and systems engineering, satellite operations, satellite flight operations skills, and downstream services, natural science, GIS, and remote sensing. So yeah, I would like to just emphasize again, out of the MULA team, satellite team, 9 of the 16 engineers are electronics and communication engineers. But somewhat we have different backgrounds, and these backgrounds somewhat complements each other. So I just like to somewhat inspire you to somewhat choose from those or research, because since in my presentation I will not cover deeper somewhat functions or deeper descriptions of those subsystems, but do your research on your own and find among those subsystems which one interests you, and so you could pursue or dig deeper on those backgrounds. So apart from the 9, we also have 2 mechanical engineers, 1 materials engineer, 1 electrical engineer, 1 geodetics and geomatics engineer, and 2 physicists. So developing a satellite is not dedicated to one course only or one background only. It is somewhat it is made up of diverse fields, so that different backgrounds could contribute and it could assess the functions of a satellite. So I just want to end my presentation with this video, if there's still time. So this is just a 2 minutes video. Can you hear the audio?
We cannot hear the audio.
I see. So let me try to reshare.
The Philippines began building
This time, sir.
satellites.
Yeah,
We
we can now
started
hear it.
small,
Thank you.
as small as a suitcase. Yet the stakes were high and the challenges were great. After the success with 6 of these small satellites, the Philippines is ready for something bigger. In December 2020, the Philippines kicked off the Multispectral Unit for Land Assessment, or MULA satellite project. Weighing around 130 kilograms, MULA will carry a true color camera that can capture higher resolution images, covering around 73,000 square kilometers of our country in one day. Data from MULA satellite will be used for addressing food security, disaster resilience, environment conservation, and protecting our national sovereignty. The Department of Science and Technology jump-started the funding of MULA. The project was jointly implemented by the DOST, Advanced Science and Technology Institute, and the University of the Philippines, Diliman, in coordination with the Philippine Space Agency, or PhilSA. 16 Filipino engineers who underwent a know-how training and transfer program in the UK are involved in building the satellite and are now part of PhilSA. The training capacitated our homegrown engineers, not just with knowledge, but the license to build more local commercial satellites in the future, leading the way for the creation of a robust and thriving space industry to support the country's space program. PhilSA will oversee the completion and launch of MULA and manage its operations. MULA in Ilocano means plant, pointing to the satellite's mission on food security. In Tagalog, it means point of origin or beginning, which symbolically signals the Philippines' foray into a new era in satellite development toward the vision of a nation bridged, uplifted, and empowered through the peaceful uses of outer space.
so for the last,
When the
okay.
Philippines began
So lastly, so I would like to share the satellite development roadmap of sa PhilSA or the Philippines. Before we created Diwata 1, Diwata 2, to develop this with our foreign partners. And there are types. These are types of scientific research and experimental satellites, which is around 500 to 100 kilograms. Also, we develop and launch Maya satellites, Maya 1, 2, 3, and 4, and also currently developing 5 and 6 in UP Diliman. So these satellites are education and technology proliferation satellites. So I am looking forward somehow or somewhere in the future that maybe MSU IIT or other universities as well, apart from UP, could develop our own nano satellites. And I'm guessing PhilSA would really want to help in that. Also, we have mission partnerships, which is greater than 300 kilograms. Novasar is not developed by Philippines or not owned by Philippines, but we are partners in this mission. We subscribe to this satellite, and currently MULA, which is on this section, operational application and specific. So these are commercial satellites which weighs 100 to 300 kilograms. So currently we are on MULA and under development. And after MULA, we are eyeing more satellites that hopefully be launched and be developed in the Philippines. So more engineers or more, not just electronics engineers, but different aspects of engineering or different sciences as well are needed. So I would like to inspire you with this, and hopefully you could be part of the space technology sector in the Philippines as well. So I guess that's it on my presentation. Thank you for listening, and you may contact Philippine Space Agency or me with this email. Thank you so much.
Okay, thank you very much, Engineer Floyd. That was indeed an interesting presentation, and how fascinating MULA satellites on its applications with the disaster risk management and the Philippine security system as well. And also, it can greatly help the private and government sector as well as the agricultural sector for the application of MULA. And also mentioned here, Engineer Lloyd, that development of a satellite technology is very multidisciplinary. So everyone can impart on developing a satellite technology, as long as you are equipped with enough skills and knowledge for this type of technology advancement. So we are now going to begin answering the questions submitted during the presentation addressed to Engineer Floyd. So we have our first question here. Can MULA or similar satellite detect the carbon dioxide concentration in the atmosphere and assist on a long-term goals pertaining to carbon neutrality? That is the first question.
Okay, so first of all, I am an expert on that field, but I will try to answer. So MULA has, as I mentioned, there are 9 bands for MULA, right? And one band for those is the aerosol or the aerosol band. So this band of satellite for the imager are mainly, its main applications would detecting air quality. So it may have a part or a capability to assess carbon. I don't know exactly if it could assess carbon dioxide, but its main purpose is for air, or the quality of air to detect.
Okay, thank you so much for that, Engineer. Next question is from ADSB and AIS station operator. His or her question is, Can MULA detect planes and ships not equipped with ADS-B and AIS systems? Sir?
I guess the AIS and ADS-B is more of a passive receiver in that sense. So, I'm not 100% sure with that because maybe there is an active transmitter and receives back the AIS-B. But as far as I know for now, more of passive lang siya. So those ships and planes with AIS and ADS-B, yun yung ano niya, yun yung sure ako na ma-detect niya for now.
Okay, thank you. Thank you, Engineer Floyd. Last, we have a question here. Please explain further the investment gain of MULA. Does it serve to prevent us from leasing from proprietors of existing satellites for research purposes only?
First question, it's not just for research purposes. The image data captured from MULA could be used since it is a commercial satellite. It could be used by immediately by different institutions or government partners for their specific applications. So not just only for research, but for the day-to-day operations. But apart from that, on the research side, yes, it is helpful on the investment would be really helpful. Those investments are quantified only based on somewhat the image value, data value that we could gain. But what's not quantifiable with that is somehow the expertise, also the skills that we gain, and how could we share these skills to other engineers. These are not quantifiable, but these are very much bigger interest or investment that we could gain from this.
Thank you, Engineer Floyd. So now, thank you for answering the inquiries of our members and our participants for this webinar. So in this juncture, we're going to award a certificate of appreciation for our first two speakers. So we have here certificate of appreciation is given to Engineer Kenneth John Ibarra for sharing sorry. Okay. For having shared his knowledge and expertise on Philippine Space Agency and overview on spacecraft system engineering during the iecep.iliganbaychapter first technical webinar 2022, Electronics Engineering and Space Science and Technology, held at Zoom web conferencing on May 7, 2022, accreditation number ECE 2009-001-378, signed Engineer 𝗘𝗟𝗘𝗖𝗧𝗥, PECE, Governor of iecep-IBC, and Engineer 𝗃𝗍𝗃𝗃𝗏𝗃𝗏, Secretary of iecep-IBC.
Okay, and we have here the certificate of appreciation is given to Engineer Floyd Ferrant for having shared his knowledge and expertise in the introduction to Multispectral Unit for Land Assessment, or MULA, satellite and its subsystems during the iecep-IBC First Technical Webinar 2022, Electronics Engineering in Space Science and Technology, held at Zoom web conferencing on May 7, 2022. Accreditation number ECE 2009-001-378, signed by the Governor of iecep-IBC, Engineer 𝗘𝗟𝗃𝗃𝗥𝗡𝗖𝗍, and the Secretary, Engineer 𝗃𝗍𝗃𝗃𝗏, PC. Okay, everyone, let's give them virtual clap for their for the sharing of their knowledge in these topics that we have discussed, this afternoon. Okay, we can see here a lot of virtual claps from the chat box. Again, thank you so much, Engineer Ibarra and Engineer Fortes.
Okay, thank you very much. So now the online quiz and evaluation for the topic presented by Engineer Floyd is now open. So participants kindly go to the link to access it. So it is already flashed on our screen as well as shared on the chat box. So you only have 15 minutes to finish, and we'll start with our next topic for this webinar after the 15 minutes time. Thank you very much, and God bless on taking the online quiz.
All right. So come back after 15 minutes, everyone.
Thank you rin po to all organizers.
Oi?
Okay, everyone, welcome back. As you can see from the chat box, we are going to have a photo op before we introduce to you our third speaker. So please, everyone, kindly turn on your camera so that we can see your beautiful faces. All right, where are the others? Okay, all right. So we will be waiting for others, so please turn on your camera. So this will serve as your remembrance for attending this today's webinar. All right. Okay, we're waiting for the others. If walang virtual background, okay lang po. Okay? But I sent to you already the link, but if you don't have it, it's okay as long as we see your beautiful faces. That's all right. Ayan. Okay na ba? All right, everyone. Ilang slide ba yan? 10. Okay, so you have to smile for about we are going to have 10 pages of our Zoom screen. So everyone, we don't know what page you are in, so make sure you smile all the way through, all right? Okay, so everyone smile. In 3, 2, 1, go. All right, next page. Next. Okay. Next. Smile. Look at the camera. Okay, not yet. Okay, smile. Okay, patience, everyone. All right, so that's all. Thank you so much for your beautiful smiles and for participating in our photo op. All right, so by the way, before we introduce our third speaker, I just want to inform everyone that the nomination for the new set of officers for the iecep IBC is now officially closed. All right, so now let's introduce our third speaker. for today's webinar. Okay, he received his bachelor's degree in electronics engineering from National Taiwan Ocean University in 1981. He obtained the master's and doctorate degrees in electrical engineering from Tatung University, Taipei, Taiwan in 1983 and 1990 respectively. Being a reserve military officer, he worked in a military factory in charge of designing an automatic primer production system and taking a part of rocket production from 1983 to 1985. He earned the 1990 URSI Young Scientist Award, and then from 1990 to 1997, he worked for Chonghua Pictures Tubes Limited Taiwan on developing new high-precision magnetic deflection yokes for cathode ray tubes. From 1997 to 1999, as a principal engineer, he then worked for Siemens Telecommunication Systems Limited Taiwan on designing the high-speed backplane for the Sonnet multiplexer. In 1999, he was back to academe, and he is now a professor of Department of Electrical Engineering of Tatung University. Simultaneously, he is now the Deputy Director of Central Research Institute of the Tatung Company. His current interests are antenna designs, electromagnetic medical engineering, electromagnetic analysis of energy research, RFID technologies, and the modeling of high-speed interconnections. So our third speaker is no other than Professor Chi-Fang Huang of Tatung University, who will be talking about antenna design for space communication. Sir?
Thank you
All right.
for your kind and long introduction for me. But actually, I supposed to cut it shorter about my introduction. And I miss you all since 4 years, not going to the 𝗘𝗟𝗃 for years. Okay. And today, let me show my PowerPoint. Okay. Okay. I have learned much about the previous speeches given by previous speakers, and I know that Philippines does to some advanced development about the satellite communication. So today I just give some brief talk about the antenna technologies. As you see in the previous speeches, satellite or space communication is a wireless, and antenna supposed to be the key components in the wireless communication because it transmitted the electromagnetic signal in the space, in the air. And since 1901, the Marconi sent the signal across the Atlantic Ocean. Actually, antenna has been more than 100 years old, actually more than 120 years. So you may wonder what's new about the antenna technologies. Actually, the antenna series, very complex, yet changed not much. As I always talk to my student, the theory you learn may be same as that my professor learned. But what's new? Applications are new. So because the communication technology advanced so much since many decades ago, so the requirement of antenna change, especially in the satellite or in the space communication. So the antenna design concept, not much change, but probably the manufacturing or the materials used in antenna change. So we need to have a basic idea about the antenna theory. And you then design and fabricate the new antenna for your satellite. Especially I learned from the previous speech, two speakers, in your satellites, you use the very small antennas that's called pitch antenna. So that's good for me to give the talk today because I will mention the pitch antenna technology. You can learn and you apply to your own technologies. Firstly, it begins about the space communication antenna. The first man-made satellite is from USSR, the previous union of the Soviet Sputnik. And Sputnik is the first man-made satellite. So since it needs the wireless communication from the satellite to the Earth, so it used the very simple antenna we call monopole antenna. So it just transmits very simple and very low speed data. Actually before it is analog signal only. So it happens in 1957. So even older than my age, 65 years old. So this is the first antenna used for the man-made objects in the space. So more than 65 years already. People always mistake that the first man step on the moon is the Armstrong, and the people mistake that the rover met on the moon is from United States. Actually, it is not true. For the unmanned rover moving on the moon is sent from the USSR in 1970. So this is the picture shows the we call Lunokhod #1, the first rover of the moon, which was sent by USSR to the moon. So you can see because the need of the communication in between the moon and the Earth, they use the so-called helical antenna and the spiral antenna. We will talk more about the need why the spiral and the helical antennas are used for the space communication. But you can see that the first kind of antenna used for the space, it is a helical antenna and the spiral antenna. So this is a very famous antenna, helical. Student can to learn to make such kind of antenna and not so hard. But it is very, very important in the space communication. Talking about the space and the communication, actually, there are some categories. Depends on the distance. You must understand that in the space communication, the signal power is very, very, very low because the distance is very, very far. And the satellite or the spacecraft are not able to carry big power. So they cannot afford the big power for the transmitter. And they are usually cannot receive the signal well because the far distance. So you need to have such kind of ideas before going further. So you will see that we can have three kinds of the wireless communication in between the so-called planets or in between the Earth and the Mars. Actually, it's quite often to set a system so-called orbiter. And even now, the United States rover on the moon, they need the orbiter. Why do you need the orbiter? because, as I say, the antenna on the rover cannot send the sufficient signal directly from the Mars to the Earth, except you just need very, very low speed data. Then you can directly send the signal from the rovers or spacecraft to the Earth. If you need to send more high-speed data, for example, pictures or some high-resolution image, you need an orbiter, because the distance in between the orbiter and the rovers on the Mars distance is shorter. So after receiving the signal from the rovers, the orbiter is with the big power to send again the signal back to the Earth. So this is a very usual systems to transmit the image or a photo from the Mars rovers to the Earth. Another one is the local communication happening on the Mars. You can see from the Facebook, there's a helicopter now on the moon, on the Mars. So in between the rovers and the helicopter, it is a very normal local wireless communication. So it's not so strange, very, very normal, just like that happening in our surrounding on the Earth. It's a local communication. So in terms of the design, antenna design, so you need to understand the different situation for such kind of three scenario: long distance and low power. So this is when you design the antenna, you must have such kind of the knowledge and the consideration. So talking about the space antenna, so you need to have some idea about the characteristics of the space antennas, because the distance is so far, so you need to very high directivity antenna. Sometimes we say high gain or high directivity, because as I say, the signal to noise ratio is very, very low. The signal is very low is because the transmitter just with very small power, because the power is from the solar panel, and the transmitter just with very small power. Why the noise is high? Because the signal transmit through the atmosphere of the Earth. The noise is very, very high. So that's why the ratio S to N is very low. That's why we need very high gain and high directivity antenna. Okay. Another consideration is the temperature, because in the space, sometimes the antenna is facing to the sun. The temperature is very, very high. And sometimes in the dark or in the night, so without any heat. So the temperature maybe below zero, several hundred degrees C. So the temperature change is quite high. The difference is very high. So it makes the material, you can see this is a spacecraft antenna. Sometimes it's with a very high temperature, sometimes a very, very low temperature. So the temperature may affect the shape of the antenna. Because the shape is affected, so the focus of the dish antenna may be changed and affect the communication very, very much. That's why I say the idea, the theory of the antenna, very, very old. But you need a new technology of a material to fabricate the antenna in the space, especially considering the temperature susceptibility. So this is a new kind of application and a new kind of the consideration. Another consideration is the polarized. This is a little theoretical. You need to check with the electromagnetic textbook. When we moving the wave through the space and arriving the Earth, because the direction is not so certain. So you need to have a diversity of the polarization of the wave to make sure can receive the signal very well. So I'm not going to further about the polarization of wave because it's a more theoretical complexity. Okay. So before going further, we need to review another theory. Is a so-called very common Friis equations. It's an equation related to the communication quantity. And you can see this equation is the PR to PT. PR is the received power. PT is the transmitted power. So this is the ratio for PR to PT ratio. You can see that this ratio is showing how much or the quality of the power signal you receive from the transmitter to receiver. The A is a so-called effective antenna aperture. So you may directly to receive to image this parameter to the shape or the dimension of the antenna. So that means bigger is better. Bigger is better sometimes. So AT is the effective aperture of the transmitting antenna, and the AR is the received aperture antenna, effective antenna aperture. D, of course, is the distance in between the transmitting antenna to the received antenna. So this is the distance of the communication. Lambda is the wavelength. So it is related to the frequency used, okay? Higher frequency, shorter wavelengths, okay? In space, the speed of the transmitted electromagnetic wave is the light speed, okay? Light speed, the constant of universe. So shorter, higher frequency, shorter wavelengths. So you may see from this equation, sometimes why you like to use the very high frequency for your wireless communication. But when using the higher frequency, the attenuation on the pace will be increased. So this is a question about the trade-off. What the frequency you need to choose, okay? But from this equation, you may simply to see a shorter wavelength is better, but it's not a universal conclusion, okay? We will see more consideration later. For long distance communication, especially in the space, as I say, you cannot provide a big power because the spacecraft is more considered the weight on the spacecraft. Lighter is better. So it cannot carry a big, huge solar panel. So it only supplies very finite power. So cannot provide the large S to N ratio. That means the signal power. But always in the environment, you may meet the high noise. So that's why the space communication may consider the especially low S to N ratio. Okay, the second point is that the is the equation I say Friis equation. We always like to have a bigger effective antenna aperture. Bigger is better. But because the spacecraft is not allow you for them to carry a big antenna in the space, because especially when launching stages or in the space traveling, always smaller is better. So it cannot allow antenna to have a sufficient effective antenna aperture. That's why we need to understand the significance of the Friis equation. when you study the electromagnetic wave, you must understand we have a so-called atom sphere windows. That means, please see this chart. We only allow some windows of the electromagnetic spectrum to enter, to be through the atom sphere. So it is not allow any kind of frequency to be through the atom sphere. Only some window, only some window. So you may see that you need to choose. You need to choose what the frequency is reasonable to be through the atmosphere. So antenna design, when you design the antenna, you need to considering the correct frequency, correct, not for any kind of frequency, not for any kind of frequency. Another best guess theory is a cross-channel theory, very important theory. I always ask my students to remember this equation, not for you to do the calculation. It's just for you to communication or to discuss the concept of the communication with people or with your colleague. For any channel capacities, that means per second, how much bits you can transmit. Actually, it depends on the bandwidth you use, bandwidth, and for the signal to noise ratio I mentioned in the previous slides. So you can see that in the space communication, the S to N ratio is always not higher, not higher. So the capacity is not so big enough. That's why only allow the very low speed communication. So you may say, why not to increase the bandwidth of the communication? Okay, good idea. But when you increase the bandwidth, it will introduce the noise in the communication. So it will lower the S to N ratio again. So usually we need to have a very narrow bandwidth in the space communication. We want to decrease the noise, increase the signal. Okay. So anyway, for space communication, based on the cross-channel series, we only allow the system to have a low-speed communication. So what can you do if the speed so low and not allow higher? What we can do is to use very giant high gain antenna on the ground. So you can see many ground station, the antenna always very huge. Why? Because based on the Friis equation, I can increase the effective aperture of the receiving end, because on the ground. So I can increase whatever I like to bigger and bigger. So based on the frequency, Friis equation, that will increase the received power. Okay, so you need to have the concept of these two equations, very important. These two equations, that's for you to do the calculation, but it is very good for you to understand the characteristics of the space communication. Okay. So now, what kinds of antenna are good candidates? Okay, so you may see often in the movie, in the media, to see the antenna designed for space communication. This antenna is very often, okay. So it can provide the high gain and the high directivity, but remember, it is temperature sensitive. For example, this picture shows the Voyager #1. It has been out of our solar system. Okay, this is the first man-made object to leave solar system. We miss that. We miss it, and leave from us. Okay, so you can see it uses this antenna. Because in the deep space, the temperature is not a problem because the temperature always very low. So no such consideration I mentioned about the sensitivity of temperature issue. But it sometimes is bulky, okay, bulky. So when you launch such kind of spacecraft, the problem is the antenna always bulky. Another consideration just I mentioned, the antenna on the first roller of the USSR, they use the helical antenna. And the helical antennas is the reasons for it to be the good candidate is that you always can provide the high gain, high directivity, and the very light, very light. Sometimes you use very special material, even much lighter, okay. But it can provide high gain, high directivity. And also, it also can generate the circular polarization wave for the communication in between the spacecraft or rovers with the Earth, because it transmits through the atmosphere. It needs circular polarization wave. The picture shows that my student designed the array with 3 helical antennas element. This antenna is not for spacecraft, not for space application, but it apply for very long distance application, okay, across the ocean. So for Philippine, actually, I emphasize much with the Joy. The communication in between the islands is very important. So if you for long distance communications, helical antenna is always a very good candidate. This is a design of my student. About the helical antenna, there's 2 modes. One is a normal mode, another axial mode. Depends on the length of the helical. So you can see there's a perimeter L. Depends on the L, how long the L is longer than the wavelength. We say this is axial mode. It's shorter than a wavelength. We say it is a normal mode. So these 2 modes will make different radiation pattern. You can see that for normal mode, it's just from the omnidirectional. We say omnidirectional. And for the axial mode, it is for, we say, both side radiation, both side. So this depends on your application. You can have a axial mode. The picture showing on the rover on the moon, the first rover on the moon, supposed to be using the axial mode because they want to have a high gain transmission from the moon to the Earth. So supposed to use the axial mode. Okay. So this is a very fundamental concept about the helical antenna. I learned from the previous speech, your satellite used the so-called patch antenna, but the formal name of this kind of antenna is so-called microstrip antenna. Patch is more easy to pronounce, I understand. This antenna, people design and fabricate the antenna on the PCB. So that's why so welcome to students, especially the graduate student, because you can make the antennas on your lab, okay? You can buy the PCB and by chemical etching or by machine etching, but you can design the fabric antenna. So people like that, okay? And in our lab, we have developed the patch antenna more than 40 years, okay, 40 years. So the picture over my professor show so many kinds of the patch antennas developed in my lab. So Professor Joe always asks me what kind of antenna your student can learn I think the pitch is always a good candidate because you can design what kinds of your thoughts, your idea by making the antenna on the PCB. It's a good candidate for you to learn. So we need to understand the characteristics of the microwave antennas. The advantage is a very band requirement. So you can design a pitch antenna for single band, multiple band. Also in the bandwidth, you can design the narrow band or wideband. I need to mention that for the last 4 or 5, 7 decades, a lot of the literature in the IEEE database about the microwave antenna development because it's so popular. It is so popular. So many professors, many students like to do such kind of the research about the microwave antenna. So you can find that from the IEEE database. Also, it can depends on your need. It can provide wave polarization for linear polarization, solar and circular polarization, whatever you need. Okay, especially it can design to be an array, so to provide the high gain or high directivity. So the picture one, you can see that this is my student design for antenna elements to be a Wi-Fi array for the point-to-point communication of the Wi-Fi system. And then this is the picture is very charming because this antenna for mass application. And the UCLA student designed such kind of the antenna for the orbiter running on the Mars. So this is amazing. Okay, NASA can provide students to design, involve such kind of project. This is so wonderful, and the student can design the antennas for the Mars application. Okay, so in this picture, show this a charming antenna. Okay, this is the as I say, array of the microwave antenna, but in the design the microwave antenna, you need to have some idea about the limitation of this kind of antenna in your mind. Sometimes it cannot handle big power because the antenna is very thin. You can see that, very thin. So it cannot handle big power. Usually not for the application of treating the big power. And as you say, it is made from the PCB. So the temperature is always a consideration too. This is when I was young, okay? When I was young, I developed the microwave antenna since 1981. So I'm doing my antenna design for my master thesis. Probably I'm the first student developing the microwave antenna in Taiwan. So you can see the black and white picture to see my setup to measure the antenna pattern, because there was not any chamber in our school, even in Taiwan. So I established my simple setup for the pattern measurement of my pitch antenna. So probably this is the first study about the pitch antenna in Taiwan in 1981. It's quite early in Asia too. So this is the array I designed in my master thesis I graduated from University from Tatung in 1983. So you can tell I'm very old. This is the antenna array I designed. Okay, so this is a pitch antenna. I even do some research for pitch antenna on missile. Okay, so you can see that I do this research in my PhD study. So this is a big cylinder, just like the missile. So I put the pitch antenna above the missile to use as a so-called fuse antenna. Fuse antenna is to check if any airplane near approximately to the missile, then it explodes itself. Okay, this is so-called fuse antenna. So this is my study about the microwave antenna on a cylinder. But this is very important. Actually, this is not easy to study because the antenna is on a curved surface. Curve. It is not a easy topic for antenna on a curved surface. Okay. So this is my study about antenna on curved surface. Before I end my speech, I think I should have an introduction about my lab in my school, and Joy Alim professor has been in our lab years ago. Actually, my lab studied the microwave and antenna since 1972, so very several decades ago. This lab was established by my professor, Professor 𝗲𝗺𝗔𝗖𝗧𝗥𝗢𝗡, okay, my advisor. So my lab is very old, very experienced. And as I mentioned, this is the first microwave antenna we developed in our school, in our lab in 1981. And in our lab, we have developed many kinds of the antennas. We have a transparent antenna for the mobile phone. This is my invention. So you may wonder how antenna is transparent. Okay, when find the literature from the IEEE. This is my invention. And we also develop antennas for digital TV. Digital TV, I guess you have such kind of system in Philippines, digital TV broadcasting with a terrestrial broadcasting. So this is for receiver to receive the digital TV. I designed such kind of antenna. We also design the antenna for car because nowadays digital TV system is able to provide the so-called mobile reception. The so-called mobile reception is that the antenna and the receiver are inside the car, Well, of course, we also develop much of antennas for notebook and computer or for some devices, and also chip antenna, very small, just a finger, very small for the mobile phone. And recently, we even developed antenna for the game, gaming headphone, okay, gaming headphone. So this is the this product has been widely very successful in the market, world market. For Xbox, I think you young student like this one, right? This antenna, this headphone is for Xbox. And the feature of this antenna is very wide and very multiple band. It meets the requirement for IEEE 802.11 ABGN AC standards. So this is a very rare design, very specific design for gaming. We also study the antenna on chip. So this is not toy. This is a model. So this is so-called antenna placement engineering. It means that how to evaluate the performance when antenna on chip, because the body of the chip is metallic. The metallic will affect the antenna radiation or receiving. So you need to have a very good evaluation about how place the antenna on the right position on the chip. So we have such kind of the capability. That's why the Navy sometimes asks us to do such kind of research. This is not toy. This is a model of the real ship. Real ship. Okay, now we need to have remind you what is the investment for the antenna development, research and development. For any kind of antenna, you need to evaluate antenna band. The so-called antenna band, the antenna design is to measure the antenna input resistance, input impedance, okay, input impedance. So you need to buy very expensive system, the so-called network analyzer. We have, you can see this is our network analyzer in our lab, very, very expensive. But nowadays, sometimes if you choose the right band, or probably you can buy the cheaper ones, but just for some proper band you need. If you need to very high frequency, especially microwave band, K band, or millimeter band, or the network analyzer will be very, very expensive. Of course, you need the chamber. And the first chamber in our school, this one, is 1986. So almost 40 years, the first one, this one. First. So this chamber was supposed the first one, including in academic or industry in Taiwan. Not mentioning the not including that one in military. Okay, in academic or industrial, this chamber is the first one for antenna measurement. Why we need the chamber to measuring the antenna? Because we need to have a directional characteristics of the antenna. So you need to have a so-called an anechoic chamber. Inside the chamber, the wave is not reflecting. Inside the chamber, the wave is not reflecting. So when you want to receive the characteristic of the direction of antenna, you need to establish a very expensive chamber. Okay, and we have the second anechoic chamber. Okay, this is but when you're talking about the chamber, always lower is expensive. Lower. That means you want to measure bigger and bigger antenna, which has lower and lower frequency band. That will be expensive. Okay. People always mistake higher is expensive. No, lower is expensive because when you measure the antenna with the lower frequency, the chamber will be very big or very big. Although we also have the EMI chamber, EMC chamber for the to comply the electronic products, general products. You are welcome to come to our lab, okay, to do the research. And also, usually we need to a software to do the simulation in design the antenna. And nowadays, the antenna is the software is very capable, especially the software is able to deal with the three-dimensional, even very, very complex in structure antenna. Okay, so you can even see the picture showing that the software can do the simulation for the shipborne antenna, the warship, the entire model. Also, including both very small antenna or very big antenna, you need the software to do the electromagnetic simulation. Okay. And also, you are welcome to come to our school, and we can show the tour with you. Okay, this is our campus. Okay, Aline and Joy Professor very familiar with the environment. So welcome you to come to Taiwan to visit our school. Thank you.
All right. So thank you so much, Professor Huang, for that very wonderful talk about antenna design. And we all know when it comes to wireless communication, the key to a good and efficient wireless communication system, particularly on space communication, is a good and efficient antenna design. So I would like to just also acknowledge Professor Huang for his help, no, in establishing the RF Lab of MSU IIT by sharing your expertise with us and in collaboration with the recently completed project, the DOSCP shared funded project with the Tatung University. And also, for those students who are here, if you are available, you can visit the RF Lab at our university and you can have our experience now the design and fabrication of your own antenna design, which is on PCB. Okay, so, and of course, you hear Professor Wang, the invitation. So for those who wants to explore antenna design, you are welcome to visit Taiwan, their school, explore their laboratory, and do your research. So I can see some professionals here and maybe those students who wants to, proceed to graduate school. You can go to Taiwan and, learn something new, and maybe you will be interested also in the antenna design field. All right. So by the way, Professor Wang, you have mentioned during your introduction that you miss Iligan City. And yes, we also missed you. And hopefully after this pandemic, you will be able to come back here and visit us. And again, share your knowledge with us. And it's always a good experience to have you here, sir, in Iligan City. Okay, so I think we will proceed now. Again, thank you so much, sir. So again, we will be proceeding on our question and answer portion. So I think we have here some questions for Professor Wang to answer. Here we have the first question. How much distance can the microstrip antennas of satellites be operational? Sir?
Okay. In terms of the distance, it depends on many parameters. The first one, the power. From the lecture I mentioned, it depends on the power. So when the power is not, there is a limitation of the power, right? Because the spacecraft always are small. So you can decrease if you want to send longer distance, the first steps you can do is lower the data speed. So this is a trade-off of the issue. If you limit the power, you want to transmit the longer, what you can do is lower down the data rate. So anyway, you can for such kind of the trade-off.
Okay, thank you so much, sir. By the way, sir, there's another question here. If those students who are interested to do their research, let's say, for example, those students who are on their master's degree, are the equipment and, the use of your equipment in your laboratory is free for them, or what's the, sir?
Oh, always welcome. My student always supposed to be can use all the equipments, okay? And even we welcome the students from the other university, I mean in Taiwan. So I always welcome. And we have a much cooperation with the industrial company. So just the example I mentioned for the game headphone, this is for a product of the Tatung company. So we also develop the antennas for the other industrial parties. Okay. So for you, always welcome. Okay.
Okay, thank you so much, sir. So you hear that, guys? Always welcome. So maybe you can have maybe how are they going to contact users through your email or something like that if they want to
Yeah,
go
sure.
and visit you?
Okay, no problem. Okay, I think Joey has my email. Okay, no problem. Okay.
All right, thank you so much, sir. So is there any other questions from our participants? Yes, we have here another question. As you discussed earlier, sir, it means that almost all of our satellites are using small bandwidth in downloading or uploading data from the satellite. Does it mean that almost all our satellites are using small bandwidth in downloading or uploading data from the satellite?
Back to the equation I mentioned for the Frisch equation and the Shannon equation. These factors always to limit is for the data transmission, the speed. So the scenario is always very typical. If you want to receive the signal for higher speed, you need to build very big antenna on the ground station, because for spacecraft, the size, weight always limit. So you cannot provide a big antenna gain. So another technology people can advance is the modulation technologies. Modulation technology in the communication theory, we can increase the data rate by some we call the digital modulation technologies. So probably the data speed can be increased in the future. Depends on the semiconductors and the advanced modulation technologies. It will be higher, I guess.
Okay, so thank you so much, sir, for that answer. Oh, is there any other question from the audience? So if there is none, so we will proceed to the presentation of the Certificate of Appreciation to Professor Chi-Fang Huang for having shared his knowledge and expertise on antenna design for space communication during the iecep-IBC First Technical Webinar 2022 with the theme Electronics Engineering in Space Science and Technology, held at Zoom web conferencing on May 7, 2022. Accreditation number ECE 2009-001-378, signed by the iecep-IBC Governor, Engineer 𝗘𝗟𝗘𝗥𝗡𝗖𝗧𝗥, and the Secretary, Engineer 𝗫𝗏𝗏𝗏. Okay, let's have our virtual clap for Professor Huang from our audience. All right, so I can see grateful hands here, sir, for having you today. All right, so now I think we are now ready for the question and quiz. Online quiz. Now, thank you so much again, sir. So everyone, we will be giving you another 15 minutes to answer the quiz for the topic number 3. All right.
Another announcement. Please return to this Zoom meeting after taking the online quiz and evaluation for our third topic, because we are going to have the closing remarks as well as the General Assembly and chapter elections for iecep-IBC. So we are encouraging the local members of iecep-IBC that are present here that please return after taking your evaluation and online quiz. Thank you. Okay, welcome back our participants for this webinar. So once again, we're pleased and would like to give thanks to our presenter for today's webinar for imparting their knowledge to our professional community. And thank you everyone for attending today's webinar. So in this juncture, as we are about to end this webinar, I would like to invite Engineer Angeline Teatro to deliver the closing remarks. Ma'am?
Good afternoon, everyone. With all the lectures we had listened today, I believe everyone here realized that space engineering technology is one track that is worth exploring. We had been given a great opportunity to explore further this area and participate and answer to the call of the government to involve in developing more technology for this field to flourish. Thank you all, the speakers and the participants, for the very successful event we have today. iecep-IBC strives hard to deliver the services we are called to undertake. This is one of the services conducting seminars relevant to today's need of technology. Once again, in behalf of iecep-IBC, thank you for your participation. Before we end this, may I remind those iecep-IBC members to please remain in the Zoom meeting so that we can go to the next part, which is the chapter's General Assembly. Thank you.
Thank you very much, Engineer Teatro, for that wonderful closing remarks. So, mga ka-ICEP, IBC, please still remain on this Zoom link since we are going to have our General Assembly. Papunta pa lang tayo sa exciting na part. So, in this General Assembly, we're going to have our governor's accomplishment reports for the previous administration, as well as the financial statement report to update our ICEP-IBC members. And at the last part, we're going to present the list of names that qualifies on the nominations for the new sets of officer for ICEP-IBC 2022. So now I will give the virtual floor to our governor, Engineer Olga Herasta. So once again, those ICEP-IBC members that are in this Zoom link, please remain. And those who are students or members of other chapter, you are free to leave the Zoom meeting, but we are encouraging those members of ICEP-IBC na please remain to the Zoom link as we are going to have our General Assembly and chapter election. So thank you very much to those participants from other chapters and those students who attend this webinar. We highly appreciate your participation for today's webinar. So now I will give the virtual floor to our governor, ICEP-IBC governor, to start her report, her accomplishment report, and financial statement report.
Good afternoon, fellow ICEP engineers. So I am requesting everyone, for non-ICEP members, you may now exit. And for ICEP members, kindly stay. And I'll be presenting now the accomplishment report for 2019 to 2021. So these are the agenda for today: accomplished report, treasurer's report, and elections of officers. So for the membership, so we have now 172 active members starting from 2019 to 2021. And as of May 6, there are already May 6, 2022, there are already 304 members, active members. So we also have conducted for 2021, we conducted a teleradio extension program at the 𝗘𝗟𝗚𝗏𝗡 Elementary School, Rongongon, Iligan City, where the members donated 118 AM and FM receivers, and together with USB flash drives to the students and also the parents of 𝗘𝗟𝗏𝗏 Elementary School to address the class requirements or to help the student in elementary school to have their lessons and through radio. Okay, we also have webinar. We conducted 2 webinars last year. So October 23 and October 30, it's all about the microelectronics session lecture series. Speakers were from analog device and Synix. The topic is all about microelectronics design. So we have here a total of 71 for first session and 168 participants for second sessions. And these are all professionals. Okay, for financial statement, so basically, this is just from 2020 to 2021. So we have here from registration, we have a total of 169,050 pesos for year 2020 and 2021, and we have received donations of 15,900. So, and currently we have 2 bank accounts. So we have BPI and MSU-IIT. So we have here active amount of 147,000, and from MSU-IIT po 41,000. So in total, we have a 464,296.42 cents for the income. And with our expenses, so we submitted a to national office a worth of 56,995 pesos for membership and also for seminar conducted. And we also have the donation of worth 30,000 during our teleradio extension program. So in total for 2021, we have remaining 377,301.42 pesos. But for 2022 expenses, it's not yet accounted pa. So this is only for 2021 December expenses statement of account. So these are the actual bank accounts we have. From BPI, we have 147,939.41, and for co-op MSU-IIT co-op, we have 41,887. And these are the amount submitted by IBC to national office. So for 2021, we have 36,943 for the whole month from January to December. And for 2020, we submitted to national the amount of 25,696. And for 2019, we submitted 38,135. This includes new ID, renewal, and also our back dues. So, and for the chapter share, these are the income. So for 2021 and 2020, for 2021, we have 75,956.25, and for 2020, we have 54,303.75 for the chapter share. And now, let's go to the elections of officers. So I'll give the floor to Sir Kevin.
Okay, thank you very much, Ma'am Olga. So before I proceed, presenting the list of name of nominees for the election of new officers, do we have any questions from our members with regards to the accomplishment reports and financial statement reports that been presented by our governor? Okay, I think there's no questions from our members of iecep-IBC. Now, on the exciting part, we are going to present the result of the nomination process for the new sets of officer of iecep-IBC for the year 2022-2023. So, since last Wednesday, we send emails to each member of the iecep-IBC the link for the nomination for positions of iecep-IBC officer. So here are the results for each position. We just choose the at least top 5 or depende sa number of nominees. Kung ang iba may nag-tie, so yung mga maraming votes ang nilagay namin sa mga list na narito. So before, these are our incumbent list of officer for iecep-IBC for 2021 chapter officer. So we have Dr. Olga Joy-Hirasta as the chapter governor, Engineer Eileen Gomera for the vice governor for internal, Engineer Angeline Teatro for the vice governor external, and yours truly, Engineer Kevin Maglinte for the vice governor education, and we have Engineer Genevieve Gatal for the secretary, Engineer Johanna May Abestano for treasurer. We have also Engineer 𝗘𝗟𝗘𝗥𝗢𝗡𝗖𝗍 for auditor, and we have Mark Eric Andam for the public relations officer. We also have our BODs, Engineer Muhammad Ali Muti, Engineer Ivy Palermo, Engineer Mark B. Miparanum, and Engineer Mercedenia A. Lambino as the immediate past governor. So here are our incumbent list officers for the iecep-IBC for the year 2021. So now, since new chapter naman ta for 2022, so we need a new sets of officers for our local chapter. So here are the results for the nomination. For the governor, here are the results for the nominees for governor. We have top 6. We have Engineer Empuerto Dennis, Engineer Herasta Olga, Engineer Hora Jefferson, Engineer Leda Michaelin, Engineer Miparanum Mark, and Engineer Parcon Adrian. So here are the names of those who are nominated for the position of governor. So it's not yet the final result for the election. So afterwards, after presenting the list of name for the nominees for each position, we'll still have the voting process to identify the specific person na mag-hold for that position. Now, nominees for Vice Governor Internal, we have Engineer Maria Bahinting, Engineer Genevieve Gatal, again, Engineer Olga Hirasta, we have Engineer Michael Gumba, we have also Engineer Mercedina Lambino, Engineer Maria Navarroza, Engineer Ivy Palermo, and Engineer Angeline Teatro. So if meron na kayong napupusuan sa mga list of names here, pwede na yan na i-take down nyo or i-notes nyo para afterwards when we send on the email the separate Google form for the election or for the voting process, kaya diretso nyo na pipiliin yung mga specific na napupusuan nyo ng mga engineers for that specific position. So that's it for the nominees for the Vice Governor Internal. Moving on, we have here the list for the nominees for Vice Governor External. So we have Engineer J. Besas, Engineer Nolly Cornell, Engineer Joseph Galindez, Engineer Jefferson Hora, Engineer Kevin Maglinte, Engineer Adrian Parcon, and lastly, we have Engineer Angeline Teatro. Next up, we have nominees for Vice Governor Education. First, we have Engineer Mark Andam. Second, we have Engineer 𝗘𝗟𝗘𝗥𝗢𝗡𝗖𝗍𝗏. Engineer Olga Hirasta, Engineer Jefferson Hora, Engineer Mercedina Lambino, Engineer Kevin Maglinte, Engineer Maria Navarrosa, and lastly, we have Engineer Angeline Teatro. So here are the list of names for the nominees for Vice Governor Education. Next, we have a list of nominees for the General Secretary. For General Secretary, we have Engineer Rhea Akot, Engineer Eileen Caberos, Engineer Genevieve Gatal, Engineer Michaelin Leda, Engineer Rochelle Sabarillo. So here are the list for the General Secretary. Next, we have list of names for nominees for the position of Treasurer. So we have Engineer Johanna Abestano, Engineer Mark Andam, Engineer Jefferson Hora, Engineer Crisel Jimenez, Engineer Mark Lubang, Engineer Johanna Kinalayo, and lastly, we have Engineer Rochelle Sabarillo. So again, here are the list of the name for the position, nominees for the position of the Treasurer. Next up, we have list of name of the nominees for the position of Auditor. So for the Auditor, we have Engineer 𝗘𝗟𝗏𝗶𝗹, Engineer Ivy Cala, Engineer Joseph Galindez, Engineer Kevin Maglinte, Engineer Melody Nogas, Engineer Ivy Palermo, Engineer Rochelle Sabarillo, Engineer Angeline Teatro, and lastly, we have Engineer Chris Tero. So again, please take down notes, those person na gusto nyong i-vote for that position. Next, we have nominees for the Public Information Officers. So first up, we have Engineer Mark Andam, Engineer Ina Kabili, Engineer Joshua Erojo Jr., Engineer Olga Hirasta, Engineer Mark Lubang, Engineer Sebastian Pacturanan, and lastly, we have Engineer Benjamin Kidlat III. So again, here's the list of the nominees for the position of Public Information Officer. Now, last is we have nominees for director. So for these directors, we are going to choose at least 5 board of directors from the list of nominees here. So 5. Then each board of directors will hold specific committee for our ICEP IBC local chapter. So here are the list of the name. So we have Engineer Jemron Arat, Engineer Vincent Baltazar, Engineer Maurice Bitoon, Engineer Haril Cabardo, Engineer Johnny Cartin, Engineer Dean Dagting, Engineer Demi Dahaw, Engineer Dennis Impuerto, Engineer Michael Gumba, Engineer Jefferson Hora, Engineer Jerwin Ladera, Engineer Mercedina Lambino, Engineer Rolando Lemens, Engineer Allen Luwaton, Engineer Kevin Maglinte, Engineer Mark Miparanom, Engineer Muhammad Muti, Engineer Lovarne Osabel, Engineer Ivy Palermo, and lastly, we have Engineer Chris Tero. So for the board of directors, we are going to choose 5 for this one. So again, those are the list of nominees for each position for the officer, a new sets of officer for ICEP IBC year 2022. Now the voting process is we're going to send a separate email to your registered, to all our local members, to your registered email address. The same with how the nomination process is done. So we're going to send you the link for the Google form for the voting process, and we will announce the result of the voting or the election on Wednesday. Sakto ba Wednesday? Okay, Wednesday next week after May 11. So the result will be posted on the iecep.iliganbaychapter official Facebook page. So don't worry if we are going to post the list of nominees as well on our iecep.ibc official page for those members na hindi naka-attend dito sa ating General Assembly. So para ma-inform and you can still vote. So the link again, once again, the link for the voting of the for the position of each voting process rather. So the link will be directly sent to your registered email to those active members of the iecep.ibc. So don't worry, the list of the nominees here are filtered based on the result of the nomination process, and list of the engineers here are also active member of the iecep.ibc. So you can search their names on the Facebook as well, so you can check the background of each nominees for the each position for our iecep.ibc. So that's it for the list of nominees for new sets of officer for iecep.ibc. So that's end our General Assembly for iecep.ibc. So now, I guess that's end our session for this afternoon. The link again, once again, the link for the election for the voting process will be sent directly to your email address, and the list of name as well. This PowerPoint of for the General Assembly will be also shared on and sent to your local to your registered email address, and will be also shared on the Facebook official page of iecep.ibc. And we are encouraging everyone, our local members, to please practice your rights to suffrage. Please participate. Since magvo-vote naman din tayo this May 9, so vote na lang din tayo dito sa ating local chapter. So minomonitor namin yan kung sino yung mga nagvo-vote. So kung hindi yung mga members na hindi magvo-vote, will be reprimanded. Okay, thank you very much, our iecep.ibc member, for staying. Then I think that's it for today. Thank you very much, and God bless everyone. Thank you. See you again on our next webinar. And for the tawag ani? Our MidCon, by the way, katong mga members natin na hindi pa naka-register for the mid-year convention for ICEP, ang ating venue is sa Davao. So please, kung yung mga gustong mag-attend for the mid-year convention, register through your myicep.net account through the event shopping. Alam naman din natin yan lahat doon. So that's it. So goodbye and thank you.
Thank you, everyone. Goodbye. Take care and God bless.
Saan pag stop share?